Hey guys, my name is Padmanandar and I am a software developer here at Programiz. I'm really glad to be your instructor for this video series on C programming. And in this series, we will learn everything you need to know to get started with C. By the end of this series, you will have a good understanding of C and programming in general. So let's get started. So, what is C programming? C is a general purpose programming language that has wide range of application. It was initially developed to rewrite Unix operating system. Apart from that, modern web browsers like Google Chrome, Firefox, database management system like MySQL, and hundreds of other applications use C. C is pretty old language created during 1970s, and with the rise of new languages like Python and JavaScript, there may arise an important question. Is C outdated? The simple answer to this is no. While these new languages have their own benefits, C is still a popular language for several reasons. C is very fast and efficient, so if you are working on an application where efficiency is must, like compilers or operating system, C is a good choice. Also, C programming allows us to access the hardware of computers on a deeper level that modern languages do not. That's why there is still a lot of demand for C programmers. According to Glassdoor, a popular job portal site, there are 18,000 active job openings for C programmers in United States. In fact, many universities teach students C programming as their first language, and it was the first programming language for me as well. There is a good reason for it. Learning C helps you understand how the software and hardware interact with each other, as C allows us to directly work with computer memory. So on the question of should you learn C, while C programming may not be the hottest language out there, we at Programiz believe every programmer should learn C eventually. It helps us to understand programming from a deeper level. Here is a line from Joel Spolsky, the founder of Stack Overflow. If you can't understand why this code copies a string, you are programming based on superstition. So, getting to the basics and understanding it is a must for every programmer. Before we learn to write our very first program, our computer needs to install a C compiler and a text editor. To make this process easier, we have created an online tool that lets you run C on the browser without installing anything. To access our online C editor, we'll open our browser and go to this URL www.programiz.com/c-programming/online-compiler. You can also find the link in the video description below. We will write our code in this area, and when I hit run, it will execute the code and show output in this area. Now, let's write our very first C program. We'll create a program called Hello World. If you do not know, a Hello World is a simple program that displays Hello World on the screen. Since it's a simple program, it is often used to introduce a new programming language to beginners. Writing even a simple program like this also involves a couple of steps. So bear with me. First, we need to create the main function int main with parentheses and with curly braces. This is the main function. It's the starting point of every C program. Now to mark the end of this program, we'll need to use return statement like this. Although this part is not necessary, it's considered a good programming practice. Now to print the text in C programming, we first need to import the file named stdio.h. For that, I'll write here #include stdio.h. For now, just remember that every C program will have this structure, and we will write the code inside this curly braces. So to print the hello world, I'll write here printf bracket inside quotation hello world, and end this statement with a semicolon. Now let me run this code. As you can see in the output, we get hello world. Here are the points to take away from this video. Every C program starts from this main function. We will write our code inside these curly braces. If you are just watching videos without actually writing code, you may soon forget and lose interest. So I highly recommend you to practice what you have watched as we move forward in this course. In this video, we will be learning about variables. More specifically, we will learn how to create variables and store data in them so that we can use them later in our program. A variable is a name given to a memory location inside our computer where we can store data. Let me give you an example. I will go to my compiler. Here you can see int is. Here the name of the variable is, and to create this variable we use this keyword int. This int keyword is a data type which indicates that the age variable can only store integer values. In C programming, every variable must have a type like this, int. We will learn about these data types in detail in next video, and in this video we will continue using int to create our variables. Once we create a variable like this, int age, we can also store data into it like age equals to 25. Here we have first created a variable named age, and then we have assigned an integer value 25 to this age variable. By the way, we have to use this semicolon at the end to mark the end of this statement, and it is also possible to create variable and assign value in a single line. Let me show you how. So instead of writing these two lines of code, we can just merge them and write a single line of code like this. So I'll cut this out. If you have watched the last video, we have used a structure that every C program follows. I'll get back to my compiler. If you remember, this is the basic structure of C program. So now let's add a variable inside this main function. Int is equals to 25. If we run this code, a variable is created but will not see any output. And to get output in C programming, we will use printf function. Before we print this variable, let's first try to print a normal text. Then in the next step, we will learn to print variables. Now to print a line of text, we use the printf function. Printf bracket inside quotation, C programming. And we will always end this statement with a semicolon. Now let me run this code, and we can see C programming is printed on the screen. By the way, our variable is also created, but we haven't seen it because we haven't printed it. Now let's print our variable. I just want to print a variable, so I'll cut this part that prints a line of text. Then I'll write printf bracket inside quotation %d, comma, and the name of the variable. In this case, the name of the variable is age. To print a variable in C programming, we use something called format specifier. Here, %d is a format specifier. Now let's run this code. As we can see, 25 is printed as an output. So what happens here is that here %d is replaced by the value of age variable. If we have to print other data like characters and decimals, we use different specifier like %c and %f, which we will discuss in the next video. Let me modify this program a bit. Here I'll write here is colon. Now let me run this code again. Now we can see this age colon is printed as it is, and %d is replaced with the value of age. Now that we know how to store data in variables, let's see how we can change their values. Yes, we can change the values of variable. That's why it is called variable. Let me give you an example. I'll go back to my previous example. Currently, the age variable stores 25. Now I'll assign a new value to this age variable, age equals to 31. And I'll print this. New age semicolon %d and comma, and again age, and end this with semicolon. Let's run this program. As you can see, initially the value of age was 25, then I changed the value of age by assigning 31. Now let me put this second line of code into a new line. For that I'll use \n, and I'll run this again, and you can see the output. It is more readable and more clearer. So here this \n is a new line character. Simply speaking, it is an enter key. If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box. So far, we saw that we can assign data directly to a variable. However, we can also assign a value of one variable to another. Let me show you an example. In this example, as you can see, we have assigned value 33 to this first number variable, and we have then printed this first number variable. Now I'll assign another variable, second number, and instead of assigning any data, I'll assign here first number. Then I'll print this \n so that we can get a readable output. Second number equals to %d and name of the variable, that is second number. Now let's see what will happen. I'll run this code and we can see first number and second number variable holds the same value 33. Let's see how this program works line by line. First, we have created this variable first number and assigned value 33 to it. Then we have printed this variable, and then we assigned another variable second number and assigned the value of the first number to it. Then we have printed the second number. We can also declare multiple variables in a single line. Let me give you an example. Here I have created two variables, variable 1 and variable 2, and I have separated them with a comma in a single line. Let me modify this program a bit. I'll assign a value 25 to this variable 2. Here the same two variables are created, however the value of variable 2 is now 25. By the way, in C programming, if we do not assign a value to a variable, its value cannot be determined. In this program, variable 1 will have some random, unpredictable value. However, some compilers may store 0 in them. Okay guys, we need your support to keep this type of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. At this point, we have covered all the basics of variable. Before ending this video, let's talk about how to choose a good variable name. If you have noticed, I have used descriptive variable names like A's and first number. We could have given variable names like A instead of A's and FN instead of first number. It works just fine. However, it's hard to understand what A means just by looking at the code. So when we use good descriptive variable names, it becomes easier to understand the code. And to make the variable name descriptive, we may need to use names having more than one word. In such cases, we follow the camel case format while giving the names to the variable. In camel case, the first word will be of small letter and the first letter of the second word will be of capital letter, like the example shown on the screen. By the way, there are some rules you need to know while creating a variable. You cannot create variable names with space in between. You cannot start variable names with numbers, and you cannot use certain words as variable names. You cannot use if as a variable name because if is a keyword. These keywords are part of C programming syntax and have special meaning in C. We will learn about these keywords as we progress through the course. It's time for Programiz quiz. Can you guess the output of this program? Hey guys, welcome back to this series on C programming. In this video, we will be learning about data types in C. More specifically, we will learn about different types of data available and how to use them. Data type specify the type of data that can be stored in variable. Let's look at this example. Here age is a variable and int is the data type of this variable. The data type determines two things. First, the type of the variable. The int type means our variable can only store integer values. Second, the size of the variable. The size of an int variable is usually 4 bytes. That means an int variable can store 2 to the power 32 distinct values. By the way, in C programming, every variable we create must have a data type assigned to it. Now let's see different data types available in C and how we can print these variables. Let me copy a list of data types here in our text editor so that it's a bit easier for us to see what they are used for. Now let's try these data types in our program one by one. We have already discussed this int type variable can only store integer values. That means it allows us to store whole numbers. The number can be 0, positive number, and negative number. Let's see an example. As we have already discussed in our previous video, this is the basic outline of every C program. So I'll continue on this and I'll assign int age equals to 10. Here you can see I have assigned 10 to our int variable age. Now let's print this using printf function. Printf bracket inside quotation %d comma name of the variable, that is age, and end this with a semicolon. Let me run the program. As we can see, 10 is printed on the screen. Here %d is replaced by the value of age variable, and if we want to make our output much more clear and readable, we can add text here like this. And let's run this again. And as you can see, our output is much more readable than before. In C programming, we use either float or double data types for creating variables that can store decimal and exponential values. The only difference between the double and float is the size. The size of float is usually 4 bytes and the size of double is usually 8 bytes. Hence, double can be used to store numbers with more precision. Now let's try to use float and double in our code. We'll start with double type. Double number equals to 12.45. Here number is a double type variable and we have also assigned a floating point value to this double variable. Now I will print this number using printf function as before. Printf bracket inside quotation %lf comma name of the variable number. For double we use %lf format specifier. So now let's run the program. As you can see, the output is printed on the screen. However, instead of 12.45, it shows 12.45 with multiple zeros after that. This is because the double variable takes 6 digits after decimal points, so it fills the remaining decimal places with random values. If we want to avoid those random values, we can print output only up to 2 decimal point. All we have to do is to add 0.2 after the percentage. Now let me run this code. As you can see, only 2 digits after the decimal point is printed. And we can also use the float data type in the same way. So I'll write float number 1 equals to 10.9 f. And I'll print this. Printf bracket inside quotation %f comma number 1. Here I have added a float variable with value 10.9, and to indicate it's a float value rather than a double value, I have added f at the end of the number. Here f is not a text, it's just the syntax we use in C for float numbers. And %f is the format specifier we use for the float variables. Now let me run this code. As you can see, our output is a bit messy, so I'll use \n here to make our output much more readable. Let's run this again. And you can see the output here. As in double, we can also remove the unwanted digits after the decimal in float as well. Let's try it. I'll add here 0.1 after the percentage and I'll run this. And as you can see, we get the desirable output. By the way, we can also use double and float to store exponential numbers. Let me give you an example. First, I will clean up my editor. Now let me store an exponential number. Double number equals to 5.5 exponential 6. Here 5.5 e6 is equals to 5.5 into 10 to the power 6. Let me print this number to verify this. Now let me run this code. As we can see, this number is indeed equals to 5.5 into 10 to the power 6. Here is a tip for you. Even though both float and double can be used for floating point numbers, we suggest you to use double simply because double can store decimal parts with more precision for larger numbers. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Now let's talk about character type data. We use the char keyword to represent character type data, and to print them we use %c format specifier. Let me give you an example. Here character is a char variable and I have assigned jet to this character variable, and notice we have used this single quotes for character data. And also notice I have used %c format specifier for the char variable. When I run the code, I'll get the character jet as an output. Technically speaking, our character data is internally stored as an integer rather than the character itself. So, if we use %d to print a char variable, we can see its equivalent integer value. So, I'll go back to my code editor. Now I'll print its integer value. Print f bracket inside quotation I'll use %d because we want to print the integer value. Now I'll run this code and we can see 122 is printed if we use %d. So when working with character, we need to remember just 3 things. 1. We use single quotation for characters. Second, to print a character we use %c format specifier. And third, characters are internally stored as integers. Before we end this video, let's talk about the size of operator, which can be used to find the size of data types such as int, double, float and char using the size of operator. Let me give you an example. Here I have used size of operator to find the size of int and double variable. It gives the size in bytes. Let me run this program. As you can see, the size of int is 4 bytes and the size of double is 8 bytes. By the way, as you see, we have mentioned it already here. The size of int is 4 bytes and the size of double is 8 bytes and the size of float is 4 bytes. Similarly, the size of char is 1 byte. In this video, we have covered 4 commonly used data types. There are many other data types in C programming which we will cover as we progress through the course. In this video, we will learn to take input from users and store it in variables. In C programming, we use the scanf function to take input from the user. The scanf function takes input from the user and store it in a variable. Similar to printf, the concept of format specifier is also used here. Let's see an example. As we have already discussed in our previous video, this is the basic outline of every C program. So I'll continue on this. First, I'll declare a variable int is. Now I will use scanf function to take the input from the user, and finally I'll use printf function to print the variable. Now let me explain it in much detail. Here age is an int variable to store the input data, and notice the scanf function. It has 2 parts. First is the format specifier that represents the type of input data. In this case, it is an integer. And second is the variable name. Notice that we have used the ampersand before the variable name. Here ampersand represents the memory address and ampersand age represents the memory address of the age variable. Don't worry about the memory address for now, we will learn about them in upcoming videos. Now, the scanf function will take the integer input from the user and store it in the address of the age variable. To verify that the input value is stored in the variable, I am also printing the variable using printf function. Now let me run this code. Here you can see the cursor. I'll provide value 22 and press enter. As you can see, the input value is printed. Here initially I get confused about where to find the cursor to input a value. So I'll print a message to ask the user for the input value using printf statement. So printf bracket inside quotation I'll write message enter input value. Now let's run this. As you can see, I get the message enter input value. I'll provide 22 and press enter. Here you can see the value is printed. Now this message enter input value make it obvious to input value. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Now that we know how the scanf function works, let's use it to take the double and character input. I'll use the same program from earlier and I'll remove this part. Now first I'll create two variables, double number and character alphabet. Then I'll use printf function to print the message for the user, enter double input, and similarly I'll use scanf function to get the input from the user. Here you can see I have used %lf to take the double input. Now I'll use printf function to show the message again, enter character input, and I'll use scanf function to take the character input from the user. And finally I'll print both the values using printf function. Now before we run this program, I'll add here \n so that we get a readable output. Now let's run this program. For double input, I'll enter 22.1 and for character input, I'll enter jet. As you can see, the double and the character values are printed as expected. If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box. In our earlier program, we took double and character input from the user. For that, we have used two scanf function. However, we can also take multiple inputs together using a single scanf function. Let me show you. I have the same code from earlier. I'll first remove this code. Now I'll change this text from double input to input values. Now in the scanf function, I'll add %c after %lf, and I'll add here ampersand alphabet after ampersand number with comma in between. Here in the scanf, %lf is used for double input and %c is used for character input. Now let's run this code. I'll provide 30.6 double value and then character value C, and then press enter. As you can see, respective values are printed. Now that I have shown you many examples of taking double and character inputs from the user, I want you to write a program to take integer and float input from the user. So go ahead and comment your program. It's time for Programiz quiz. What is the correct way to take double input? In this video, we will learn to write comments in C programming. We'll also see why comments are important. Comments are hints that we add to our program to make our code easier to understand. Let's see an example. I have this program that prints a variable. To make this code a bit more readable, I can add comment here like this. Create a variable. And I'll add another comment here. Print the value of data variable. Here these lines that start with 2 forward slashes are comments. We add them to make our program easier to understand for everyone. Let's see what happens when we run this program. As you can see, the program runs normally without any issue. This is because C programming completely ignores the line that start with double forward slashes. We can also put the comment and our code in the same line. For that, I'll cut this and put this in the same line with the code. I'll do this for this comment as well. Now I'll run this code and see what happens. You can see that the code before 2 forward slashes are executed and all comments are ignored. We can add any number of comments anywhere in our program. However, if our code is self-explanatory, there is no need to use comments. This only makes our code very messy. So I'll remove these comments from the program. We can also use comments to debug our code. It is a common practice to comment out code so that it is ignored rather than removing them completely. Let me give you an example. In this example, I have created a program to take age and height from the user. Suppose in this program, I was not required to take the height input from the user. So instead of removing the code related to height, what I can do is I can simply add a double forward slash at the beginning of this line so that they become comments. So to make them comments, I'll just add forward slash here. So I am adding forward slash to every code that is related to height. Now the codes will be there if we need them in future, but they are completely ignored by the C compiler. Now let me run this code. As you can see, it says enter the age. I'll enter 29 and press enter. Here the output says age equals to 29, but these lines are completely ignored. Now later on, if we need height again, all we need to do is to remove these forward slashes. And they will now become statement, not comment. Now let me run this code again. I'll enter the age 29 and I'll add here height equals to 11, and you can see the output on the screen. A little pro tip for you, remember the keyboard shortcut to apply comments. In most text editors, it's Ctrl// if you are on Windows and Command/ if you are on Mac. This will be very helpful in debugging our code. In C programming, there is another type of comment that allow us to comment on multiple lines at once. Let me give you an example. Suppose we want to comment these 3 lines. We can do that by typing / and asterisk at the beginning and asterisk and / at the end. So let's do that. / and asterisk at the beginning and asterisk and / at the end. Now let's run this code. I'll enter 29. As you can see, the code runs without any errors and these comments are ignored. I can also use keyboard shortcut to use multi-line comments. Let me show you. First, I'll remove this / and asterisk at the beginning, and I'll also remove this asterisk and / at the end. And I will select these 3 lines and press Ctrl+Shift /. As you can see, these lines are now commented. If you are on Mac, you can press Command+Shift /. Here, instead of Ctrl+Shift /, if I press Ctrl only, these 3 lines will be commented at once, but they will be commented with single line comments. The multi-line comments are useful if we need to explain the code a bit more and add more text to understand the code. Now let's take a moment to discuss why comments are important. Imagine that you are working on a huge project for a client. Since you were on a tight schedule, you decide to ignore comments. You successfully delivered it to the client and clients are happy about it. Fast forward in a couple of months, the client wants to update some features of project. Since you were the one who developed the project, the client wants you to make the change. Without comments, you will forget the reason why you wrote a particular piece of code a certain way. And you will end up spending a lot of time looking at your own code and trying to understand it. Now, if you had commented the code, it would have been easier for you. Comments are even more important if you are working in a group. It makes it easier for other developers to understand and use your code. That being said, comments are not and should not be used as a substitute to explain poorly written code. You should always try to write clean, understandable code and then use comment as an addition. It's time for Programiz quiz. What is the correct way to comment in C programming? In C programming, an operator is a special symbol that is used to perform operations on values and variables. We have already used one operator many times in our program without even realizing it's the equal to operator. This is an assignment operator that assigns the value to a variable. For example, int age equals to 24. Here, value 24 is assigned to the age variable. There are many other assignment operators, but before we learn about them, let's first learn about arithmetic operators. Arithmetic operators are basic operators like plus and minus that allow us to perform arithmetic operations. Here is the list of all arithmetic operators available in C programming. Before we start, let me first copy all the arithmetic operators in the code editor. Now, we will learn about these operators next. Let's start with addition operator. The addition operator represented by the plus symbol adds 2 values or variables. Let's see an example. Here is a basic outline of a C program. Now I'll create a variable, say x, int x equals to 12. Then I'll do something like int result equals x plus 8. And I'll print this using printf function, printf bracket inside quotation %t, comma, result. Now let me run this code. As you can see, 20 is printed. So what's happening here is value 8 is added to the value of x, which is equals to 12, and they are added by the addition operator, and the equal to operator is storing the result in the result variable. And then when I print the result, I get 12 plus 8, which is equals to 20. Instead of storing the result in a variable, I can simply print the result. For this, I'll remove the result variable. So inside the print statement, I'll add here x plus 8 instead of result, and I'll run this, and as before we can see 20 is printed on the screen. But personally, I would like to use the variable. It makes the code much more elegant and organized. So I'll revert back to my previous code and I'll put here result as before. We can also use the addition operator to perform addition of two floating point numbers. Let's see an example. I'll change the int variable to double, and int result to double result, and I'll assign a floating point number. So I'll make this 12 to 12.57. Then we will add x variable with another floating point number, say 8.67. Since I am adding two floating point numbers, the result will also be floating point number. So I'll change the data type of result to double using %lf format specifier, and I'll put 0.2 before lf so that we can print the double value up to 2 decimal places. Now let me run this code. Now as you can see, we get double result 21.24 as an output. We can also add a double variable and an int variable using addition operator. I'll use the same code and create an int variable y, int y equals 8. So I have assigned an int variable with a value 8 to it. Now in the place of 8.67, I'll use y variable. Now let's run this code. As you can see, I get an output 20.57. When we add a floating point number with a whole number, the whole number is converted into a floating point number. Hence, we get a floating point number as a result. Similarly, we can perform subtraction and multiplication using minus and asterisk operator respectively. Go ahead and try it by yourself and leave your code in the comment below. In computer programming, the division operator works differently when used with integers and floating point number. So let's first see how it works for integer. I'll create an int variable x and assign a value 12 to this, and let's create an int result and assign x divided by 8, and I'll print this using printf function inside quotation %d comma result. Here you can see I have used / for the division, and notice I have used only the integer values for this. Now let me run this code. As you can see, I get 1 as an output. However, 12 divided by 8 should give 1.5, but we got 1 because the division operator, when used with integers, gives only the quotient value. Now, to get the exact result, we use division operator with floating point number. Let me change this variable to double type. So I'll change int x to double x and int result to double result. Then I'll make this integer value 12 to floating point value, and I'll change this 8 to 8.00. Here I have changed the data type of x to double and assigned the value 12.00 instead of 12, and I changed the value of 8 to 8.00. And since the result will be a floating point number, I changed the data type of result to double. For that, I'll do %lf and I'll put here 0.2 so that we'll get the output up to 2 decimal places. Now I'll run this code. You can see the expected output 1.50 is printed. We know that the division operator gives quotients when used with integer data. Now, if we need to find the remainder after division, we use the remainder operator. It is also called modulus operator. Let's use the earlier code. I'll replace this division operator with modulus operator and I'll run this. You can see I get 4 as an output because when we divide 12 by 8, the remainder is 4. The remainder operator can only be used with integer data. If you use it with floating point numbers, you will get an error. Go ahead and try it yourself. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. So
far we have covered some of the basic operations. Now let's learn about the increment and decrement operator. The increment is used to increase a value by 1. Similarly, decrement operator is used to decrease the value by 1. We use the plus sign as an increment operator and minus sign as a decrement operator. Let's see an example. Here I have a variable with value 12. Now inside the print statement, I'll print the variable with increment operator. So I'll add here plus plus. As you can see, I have used plus plus with x. Now let's run this code. As expected, the plus plus sign increases the value of x by 1 and we get 13 as an output. Similarly, we can use the decrement operator to decrease the value by 1. Let's see an example. In this same code, instead of plus plus, I'll use minus minus in front of x and I'll run this again. As you can see, value is decreased to 11. Here I have shown you example of prefix increment and prefix decrement of variable. However, we can also use it after the variable in a postfix form like x plus plus for increment and x minus minus for decrement. They work in a similar manner, but there is one small difference between them. If you want to learn how they work differently, you can visit the tutorial in our website programiz.com. The link is in the video description below. So far, we have been using single operator in an expression. However, there might be a case where we have to use multiple operators in a single expression. Let me show you an example. So in our previous example, I'll change this value of x equals to 12 to 4 divided by 2 plus 6 multiplied by 5 and we'll minus 1 and we'll print this using printf function. Now let's run this. Here the output is 31. This is because the division operator is executed first. Then the multiplication is executed. Then the addition is performed between the result of division and multiplication, and finally minus operator is executed. That means 4 divided by 2 equals to 2, 6 multiplied by 5 is 30 and 2 plus 30 equals to 32 minus 1 equals to 31. So that is our output. Now the main question is why division is executed first? Well, this is due to the concept called precedence and associativity. Operators with higher precedence are executed first and operators with lower precedence are executed last. Here the division has higher precedence than addition and subtraction. So we'll learn about this in later videos. Before we move ahead, one quick tip for you. We should build a habit of using parentheses to make it easier to understand the code. For example, in my previous code, I'll add parentheses like, here I'll add parentheses between 4 and 2 and I'll add another parenthesis between 6 and 5. Now you can see our code is much more organized than before. It's time for Programiz quiz. What is the value of x in the following code? In this video, we will learn to convert one data type to another in C. We will also learn about different types of type conversion in C programming. Before we talk about type conversion, let's quickly see an example. Here we have two int variables a and b with value 5 and 9 respectively, and we have used plus operator to add these two numbers. Now let's run this code. You can see we get 14 as an output, which is 5 plus 9. Now let me change one of the data to char type. So here I'll change the data type of a to char. Char a equals to 5 and I'll put here single quotation around 5. Now we are performing addition between integer and character variable. Now let me run this program. As you can see that the code runs without any error and we get 62 as an output. Let's see what's happening here. We are adding character value 5 and an integer value 9. In this case, the compiler automatically converts this character value into ASCII value. So the character 5 is converted into its ASCII value, which is 53. So the final output is 53 plus 9 equals to 62. Now let's try another example. This time I'll change this character data to double and make this 5 into a floating point number, and I'll add here 0.67. Now in this case we are adding double and int type variable. Now I'll run this code. Here we get 14 as an output. It looks like the double value is converted into int value 5 and then added to 9, which gives us 14. But that's not the case here. Actually, the int value 9 is converted into double value 9.00. Then it is added to the double value 5.67, making it 14.67. However, the sum is stored in the result variable, which is of int type. So the double type sum 14.67 is now converted to an int type value 14. Hence, we get the output 14. We can verify this by changing the data type of result variable. Let me show you. I'll change this result variable to double. So double result equals to a plus b. Similarly, I'll use %lf instead of %d. And now I'll run this. This time you will see 14.67 with multiple zeros after that. You might be wondering why the int value is converted into double. Why not the double converted to int? Well, the type conversion occurs according to the data type hierarchy. Here the data type that is lower in this hierarchy is always converted to the data type that comes higher. For example, between char and int, char data type is converted to int, and between int and double, the int data type is converted to double. We can say that the lower data type is promoted to higher data type. However, if you have noticed, we have assigned double value to an int variable. The double value is converted to the int value. This is because during the assignment, the data type on the right of the assignment operator is always converted to the data type on the left. In this case, sometimes the higher data type can also be demoted to lower data type. Let's see an example. I'll create an int variable, int a equals to 5.67. I'll print this using printf function %d, comma a. Now when I run this, you can see that we get the integer value 5 as an output. During the conversion from the higher data type like double to lower data type like int, there might be loss of some data. In our program, the data 5.67 is converted to 5. There is a loss of data 0.67 during this conversion. So we should be careful during this type of conversion. Here, all the type conversion are happening automatically. This is called implicit type conversion. We can also forcefully convert one data type to another. This type of conversion is called explicit type conversion.
If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box.
Before we learn about explicit type conversion, let's get back to our earlier code. Here we are adding double type variable a with an int type variable b. Normally we know that the int type variable b will be converted to a double type and then the addition is performed. What if we want the double value to be converted to int and then add the int value? This is where we use explicit type conversion. Let me show you. I'll add int inside this parenthesis in front of a. So here the int inside the bracket before a tells the compiler to convert the variable a to int type. Now let me run this code. As you can see, we get 14.000 as an output. Here this int inside the bracket changes the double value 5.67 to int and then adds this value 9 to it, and then the sum is 14, which is assigned to result variable. Since the result is double variable, 14 is converted to double and gives us output 14.000 and multiple other zeros after that. Since the result is also int, I can now change the data type of result into int. And don't forget to change the format specifier from %lf to %d, and then I'll run this again. This time we'll get 14 as an output. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Similarly, we can also convert an int data type to double by using double keyword inside the bracket before the variable name. Let me show you. Here I'll remove this code. Now I'll create two int variable, int a and assign value 9, and create another int variable, int b equals to 2. Now I'll perform the division between a and b and store the result in a double variable. So double result equals a divided by b. Print this, print f bracket inside quotation %lf comma result. Now let me run this code. Here we get 4 as an output, not 4.5. This is because we performed division between two integer value. The result will be quotient, so we get 4 as an output, which is the quotient value. However, we want the actual result 4.5 after the division. Then we can use the explicit type conversion to convert one of the variable to double and perform division. So here I'll add double before the variable a. Now let's run this. Now we get 4.5 as output. Here we have only converted the variable a to double type, but still we get the output. This is because now the variable a is of double type, and if we perform operation between double and int, the int data type is implicitly converted to the double type, hence b here is also converted to double type. Now the division between 9.0 and 2.0 is equals to 4.5. It's time for Programiz quiz. What is the value of result in the following statement? Just like integer and double, Boolean is a data type that can store only two values, either true or false. We use the bool keyword to create Boolean type variables. However, to create a Boolean type variable, we must import the std_bool header file first. Let's see an example. Here I have a basic C program. Now I'll first include std_bool.h, just like stdio.h. Now let's create two Boolean variables, bool value 1 equals true, and another bool value 2 equals false. Now we'll print these variables. We know that we use format specifiers to print variables in C. However, there is no format specifier for bool type variable. So how do you print a Boolean variable? Well, we use the %d, just like printing integer values. This is because in C programming, Boolean values are represented by integer data. False is represented by 0 and true is represented by 1, or all the values except 0. Now let's print these variables. Now I'll print this using printf statement using %d format specifier, value 1, and I'll put some space here. Then I'll print another value 2 using printf statement. So here we'll use %d format specifier and value 2, and we'll put some space here, and I'll run this. You can see 1 is printed for true and 0 is printed for false.
One thing you should remember is that C is a case-sensitive language and we cannot use true and false with capital T and capital F. Let me show you. I'll replace this small t with capital T and I'll replace this small f with capital F and I'll run this. As you can see, I get an error. This is because true with small t is different from true with capital T. Now that we know about the Booleans, let's learn about comparison and logical operators. These operators are used to create Boolean expressions that return Boolean values. Let's start with comparison operator. I'll first copy a list of all comparison operators in our text editor so that it's easier for us to use them. Now let's go through them one by one. I'll start with greater than operator. The greater than operator checks if the value is greater than another value. Let's see an example. Here I am using greater than operator to check if 12 is greater than 9 and assign the result to the value variable. Since 12 is greater than 9, the output will be true. So let's run this code. As you can see, I get 1 as output, which represents true. Now let's change the value of 12 to 5. Now I'll run this code again. This time we get output 0, which represents false. It's because 5 is not greater than 9, so the greater than operator results false. Similarly, the less than operator checks if the value is less than another value. Here I'll simply change the greater than sign to less than sign. The value 5 is less than 9, so the output will be true. Let's run this code. As expected, we get the output 1, which is true. Now let me change the value 5 to 9 and I'll run this code again. Here I'll get 0 as output because 9 is not less than 9. The equal to operator compares two values and return true if the value are equal. I'll use the same code and change the less than sign to equal to sign. Here 9 is equal to 9, so we should get true as output. Let's run this code. As expected, we get 1 as output. Now let me change this 9 to 6. By just looking at this, you can tell the output is going to be false. Let me run this code. As expected, we get 0, which means false in C programming. Similarly, there is not equal to operator. It does exactly the opposite of what equal to operator does. It checks if two values are not equal. Here I'll change this equal to operator to not equal to. Here we are using not equal to operator between 9 and 6. Now let's run this code. I get 1 as output because 9 is not equal to 6. So result is true. In C programming, there are also some compound comparator operators like greater than equal to. This operator gives true if a value is either greater than or equal to another value. I'll use the same code and I'll change this value to 9 is greater than and equals to 6. Now, what do you think the output of this code will be? I'll run this. And yes, you guessed it right, the output is 1 because 9 is greater than 6, so the result is true. Similarly, there is less than or equal to operator that does the exact opposite of greater than or equal to. Let's change the operator here. Now let's change the operator here. I will run this code. You can see I get 0 because 9 is neither less than or equal to 6. We can also use this comparator operator with floating point numbers. So I'll change the value 9 to 9.34 and change this 6 to 6.87. Now we are checking if 9.34 is less than or equal to 6.87. I'll run this code. As you can see, I get the output 0. That means the condition is false. Till now, we have used comparison operators to compare two values. However, we can also use them to compare variables. Let's see an example. I'll create two variables, int num1 equals 9 and another variable int num2 equals 6. Now let's compare these two variables. To compare that, we'll create bool value equals num1 is greater than num2. Here I am checking num1 is greater than num2. Now let's print this using print statement. Print f bracket inside quotation %d comma value. Now I'll run this code. We get output 1 because the value of num1 equals to 9 is greater than value of num2, that is equals to 6. We can also use comparison operators with variables and value. I'll remove this num2 and I'll remove this num2 here as well and put here value 6, and I'll run this again. As you can see, code runs perfectly fine and we get the output as before. These are the comparison operators that are used in C programming. They all return a Boolean value, and the expression where they are used is called Boolean expressions. In our previous example, the code num1 greater than 6 is a Boolean expression. Boolean expression check particular condition and results either true or false, and based on the result we can perform different actions. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the videos, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Now let's move to logical operators. Logical operators are used with Boolean expression to perform logical operations. C programming has 3 logical operators, and they are AND, OR and NOT. Let's copy them in our code editor and learn them one by one. We use the 2 ampersand sign for the AND operator. Let me show you an example. I'll create 2 variables, age and height, with value 18 and 6.3. So let's do that. Int age equals 18 and double height equals 6.3. Now I'll create another variable, bool result, where I'll assign 2 Boolean expression. First, to check if age is greater than or equal to 18. So equals to age is greater than or equals to 18. And second, to check if height is greater than 6. So height is greater than 6. And now I'll use AND operator to join them. So let me complete this program. Here I'll add print statement. Print f bracket inside quotation %d comma result. Here I have used AND between 2 Boolean expressions. The operator returns true if both expressions are true. Let me run this code. Here I get 1 as output because age is equals to 18. So this Boolean expression returns true, and height is also greater than 6. So this Boolean expression returns true as well. Hence we get the final result that is also true. Now let me change the value of 18 to 16. So this expression is greater than equals to 18 becomes false. Now let me run this code. As you can see, we get output 0. This is because the AND operator returns true only if both the expressions are true. However, the value of age is 16, so this expression is false. Hence, we get the final result 0. That is false in C programming. Now let's learn about logical OR operator. We use double pipe symbol as the OR operator. The OR operator returns true if one of the Boolean expression is true. Let me show you. Here I'll replace this AND with OR. Here this expression is false. However, this expression is true, so the result will be true. Let me run this code. As expected, we get 1 as output. On like and or, the not operator is used with only one Boolean expression. We use the exclamation mark as the not operator. The not operator simply reverses the result of Boolean expression. If the expression is true, it returns false, and if the expression is false, it returns true. Let's see an example. I'll use the same code as before. Here I'll remove this double variable, and this expression height is greater than 6, and I'll use not operator before this expression. Here this expression is false, so the not operator reverses the value, hence the final results become true. Let me run this code. As expected, we get 1 as output. Now let's change the greater than operator to less than or equal to operator. Here the Boolean expression is true, so the result will be false because of this not operator. Now let me run this code. As you can see, we get 0 as output. Boolean expressions are very useful in decision making and loops. They are used to check particular condition, and based on the condition we can make some decision. Suppose you want to check if a person is eligible to vote. Then we can use Boolean expression to check if the age of the person is greater than 18. And depending upon the result of the Boolean expression, we can decide if the person can vote or not. This is how we can create decision-making programs using Boolean expression. It's time for Programiz quiz. Which of the following code returns false? In this video, we'll learn about if-else statement in C programming. We'll learn to create decision-making programs that perform one set of tasks under a certain condition and another set of tasks under different condition. In C programming, we use the if statement to create programs that can make decision. Let's start by looking at the syntax of the if statement. The if statement starts with if keyword and is followed by the test condition inside the parenthesis. This test condition is a Boolean expression that results in either true or false. If the test condition is true, the body of if statement is executed, otherwise it is skipped from the execution. Now that you know the syntax of if statement, let's try a working example. Suppose there is an election going on, and to cast the vote, your age must be 18 or more. If your age is 18 or more, we'll print you are eligible to vote. Let's see how we can implement this. Here I have a basic C program. Now I'll create a variable to store age, int age. Now I'll ask the user to input their age. For that, I'll use printf statement and print the message like enter your age. Then I'll use scanf statement to take the input. So %d, comma, ampersand age. Then I'll use if condition to check if age is greater than or equals to 18. If this condition is true, I'll print you are eligible to vote. Now let me run this program. Here I'll provide 31 as the age and I'll press enter. As you can see, you are eligible to vote is printed. Here the value is 31, so our test condition is greater than or equals to 18 is true. That is why this print statement is executed. Now let me run this program again. This time instead of 31, I'll enter 15. This time nothing is printed on the screen. This is because the age is 15, so the test condition age is greater than or equals to 18 is false, so the body of the if statement is skipped. Our program is working fine, but it is not printing anything when the age is less than 18. We might want to print something like, sorry, you are not eligible to vote when age is less than 18. So I'll add another if statement. So I'll say if age is less than 18, I'll print sorry, you are not eligible to vote. Now I'll run this code and I'll enter 15 again. Here you can see, sorry, you are not eligible to vote is printed. This is because age is 15, so this condition age is greater than or equals to 18 is false, therefore this statement is skipped. However, this condition age is less than 18 is true, so this statement is executed.
If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box.
I have this code from the last segment. I'll remove this code to get the user input, and I'll manually assign the value of age equals to 15 so that it's easier to focus on the logic of the if statement. In this program, I have used two if statements to perform two different tasks. We know that the person is eligible to vote only if the age is greater than or equals to 18. And if the condition is not met, we know that the person is not eligible to vote. In such cases, instead of writing the second if statement with the condition, we can use else clause. Let's first look at the syntax of the if statement with the else clause. On your screen, you can see how it looks. So what happens here is, if our test condition is true, statement inside the body of if statement is executed, and if it is false, statements inside the body of else are executed. Now getting back to our code to check if the person is eligible to vote or not, in this program I'll use the else clause instead of this second if statement. So I'll remove this second if statement and replace it with else. Now let me read this code in plain English. Age is greater than or equals to 18, then print you are eligible to vote, else print sorry you are not eligible to vote. Now when I run this code, you can see sorry you are not eligible to vote is printed. This is because age is 15, which is not greater than or equals to 18, so we get the output sorry you are not eligible to vote. Okay guys, we need your support to keep this type of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button, hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. The if statement with else clause allow us to make a choice from two different options. However, sometimes we need to make choice from more than two options. In those cases, we can use else if clause with test condition. Let's see the syntax first. The if statement checks the first condition inside the if statement. If it is true, the body of if is executed, and the statement 2 and the statement 3 are skipped. However, if the first test condition is false, the control of the program jumps to the second test condition. If this condition is true, the body of the else if statement is executed and other statements are skipped. If both the test condition 1 and the test condition 2 are false, then only the else body is executed. If necessary, we can add as many else if clauses as we want for our program to work, and among all those alternatives, only a single block of code is executed. Now we know how the else if clause works. Let's get back to our code to check whether a person can vote or not. Here the age variable stores the age of the person. Currently the age of oldest person is 120. So I want this program to consider age greater than 120 as invalid. Similarly, the age cannot be negative, so I also want to mark less than 0 as invalid. Now I want to include these two additional conditions in our program. For that I'll use else if clause. Now I'll modify this code. So if age is greater than 120, I'll print invalid is. Invalid is. And else if, so if is less than 0, that is negative value, then we'll print is invalid is. I'll change this if to else if. So as you can see, I have included one if condition, two else if condition, and finally one else condition. Here I'll change the value from 15 to 130. Now I'll run this code. Here the age is greater than 120, so we get invalid age as our output. Now let's change the value of this age from 130 to -4, and let's run this again. This time we get invalid age again. So this is the condition of else if. Here age is less than 0, so the output we got is invalid age. Now we can add as many else if condition as we want. Here we can see these two conditions are performing the same task, printing the invalid age. In this case, we can combine both the condition together using logical operator. Here the age is invalid if it is either greater than 120 or less than 0. Or let me modify this code. So I'll cut this. I'll use logical OR and put here is less than 0. So I'll change this value from -4 to -1, and when I run this code, I get invalid age as output. Now as long as the age is an integer number, our program works correctly, and the extra condition makes sure the age is neither greater than 120 or less than 0. And for any other value of age, the program runs as intended. If we provide the age equals to 50, so let's do that. I'll provide the value of age equals to 50. I'll run this. Now this person is eligible to vote. Before we end this video, one quick tip for you. If the body if-else block has only one statement like this, then we can omit the curly braces of the if block like this. As you can see, the syntax of the if statement is pretty simple. The harder part is the logic behind the test conditions. So you will get better at creating test condition with practice. Also, be sure to check our video on the comparison and logical operators that are used to create the test condition. The link will be in the video description below. We have covered a lot in this video. It's time for you to practice what we have learned. Here is one programming challenge for you to solve. Can you create a program to check whether a number is positive, negative, or 0? To create this program, create a variable named number and assign a double value to it based on the user input. Then using an if statement, check if the number variable is positive, negative, or 0. If the number is positive, print the number is positive. If the number is negative, print the number is negative. And if the number is 0, print the number is 0. It's time for programming quiz. What is the output of following code? In this video, we'll learn about the ternary operator, which can be used to replace if-else statement in certain situations to make our code look cleaner. Let's start with syntax of ternary operator. On the screen, you can see the basic structure of ternary operator. The ternary operator starts with the test condition, like x is less than 0 or name equals to Padma or any other Boolean expression that evaluates to true or false. If this test condition results in true, this first expression before the colon is executed. And if the test condition is false, then the second expression after the colon is executed. Here you can see there are 3 operands, hence the name ternary operator. Now you know the syntax of ternary operator, let's see an example. Here you can see the basic C program. Now I'll create an int variable age and assign value 15 to this. Then I'll create a ternary operator with the condition age is greater than or equals to 18. And if this condition is true, I'll print you can vote. So printf inside quotation I'll put you can vote, and if that condition is false I'll print you cannot vote. So I'll end this statement with a semicolon. Now let me run this code. As you can see, you cannot vote is printed. Here age is equals to 15, so this condition becomes 15 is greater than or equals to 18, which is false. So this print statement after the colon is printed on the screen. Now let me change this value from 15 to 24. Now this condition becomes 24 is greater than or equals to 18, which is true. So this print statement before the colon should be executed. Now let's run this code. As expected, we get you can vote as output. Here we have used print statement as expression inside the ternary operator. However, we can also store value from ternary operator to a variable and use the variable later. Let's see an example. I'll remove this line and create a char variable called operator, and I'll assign plus to this. Then I'll create an integer variable num1 and I'll assign a value a to this, and I'll create another int variable int num2 and I'll assign value 7 to this. Now I'll cut this ternary operator and start with a new condition, and I'll check if operator is equals to plus, and if this condition is true I'll add num1 with num2 and I'll add colon here, and if this condition is false I'll subtract num2 from num1, so num1 minus num2. These expressions are returning some value, so I'll assign this ternary operator to a variable, so say int result, and I'll print this variable using printf statement. Printf inside quotation I'll use %d format specifier and the name of the variable, that is result. I'll run this code and you can see we get 15 as output, which is the sum of 8 and 7. Here the operator is equals to plus, so this condition is true and addition is performed between num1 and num2. Depending upon your requirement, you can either print values directly or assign value to a variable from a ternary operator. However, if you plan to use values later in the program, it's a good idea to store value in a variable. In some of the cases, we can replace the if-else statement with a ternary operator. This will make our code cleaner and shorter. Let me show you an example. On your screen, you can see a program that checks if you can vote or not using the if-else statement on the right and ternary operator on the left. Both the program are doing the same task and checking if a person can vote or not. And you can see the use of ternary operator has made our code cleaner and shorter. In such programs where we need to do a single task inside the if-else statement, we can use the ternary operator in a place of if-else. However, if there are multiple lines of code inside the if-else statement, we should never replace that with a ternary operator. This will make our code more confusing and messy. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Now to revise what we have learned, here is one programming task for you to solve. Can you create a program to check whether a number is odd or even? To create this program, create a variable named number and assign a value to it. Then using a ternary operator, check if the number variable is odd or even. If the number is odd, print the number is odd, and if the number is even, print the number is even. It's time for Programiz quiz. What is the correct ternary equivalent of the following if-else statement? In this video, we'll learn about the switch statement and how to use it to make decision-making programs in C programming. Here we will also create a calculator using switch statement. Before we learn about switch statement, let's consider a scenario. We are given a number between 1 to 7, and based on the number we have to print the day of a week. For example, if the number is 1, then the day is Sunday, and if the number is 2, then the day is Monday, and so on. Now we can use the if-else statement for this. However, for every number there should be a separate condition. This will make our program look messy and difficult to understand. For such type of problems, where we have to choose from multiple options, a better approach will be switch statement. Let's start with the syntax of the switch statement first. The switch statement starts with the switch keyword followed by the variable or expression inside the parenthesis. Inside the switch statement, we can create multiple cases, and each cases will have its own value. Now the value of variable or expression is compared with the value of individual cases. If the result of the variable or expression is equals to value 1, then the body of case 1 is executed. Similarly, if the result is value 2, then the body of case 2 is executed, and so on. However, if the result does not match any case, then the body of default is executed. Now let's get back to our original problem of finding the days of the week. On the screen you can see the basic C program. Now I'll create a variable number, int number. Then I'll ask the user to enter the number between 1 to 7. So I'll use printf statement and I'll print the message like enter the number between 1 to 7 and store the value to the number variable. So scanf side quotation %d comma ampersand name of the variable, that is number. Then I'll create the switch statement that will print the day of the week. As we have already discussed, we'll use switch keyword, and then inside parenthesis we'll put variable or expression. In this case we have variable number, so I'll put number here, then a curly braces. Inside this curly braces we'll add cases. So when the case is 1, I'll print Sunday, and I'll use break statement after that. I'll talk about this break statement later on the video, so let's continue. When the case is 2, I'll print Monday. So Monday, and break statement. So what I will do is I'll copy this and paste this 5 more times, and at the end I'll put default and I'll print invalid number. So invalid number. Now the case 1 and case 2 is already done, so I'll edit from case 3, and case 3 is Tuesday. Similarly, case 4 is Wednesday, and case 5 is Thursday. So we'll write Thursday here. Then case 6 is Friday. And finally, case 7 is Saturday. So let's make this as capital. So here I have included cases from case 1 to case 7, and if the user input 1, then this part of code is executed and Sunday will be printed on the screen. And if the user input 2, then this part of code will be executed and Monday will be printed on the screen. However, if the user input any number except 1 to 7, then the code inside default will be executed and invalid number is printed on the screen. Now let me run this program. I'll enter 5. Now the input value 5 matched this case number 5, and Thursday is printed on the screen. Now let me run this code again. This time I'll enter 6. As expected, we get Friday as output. Now once again I'll run this code, and this time I'll enter the number that does not lies between 1 to 7, so I'll enter 9. And as you can see, I got the output invalid number, which is present inside the default. Here the default case is optional. We can remove this if we are sure that the input value matches one of the cases. Go ahead and remove the default value and try the code. Here, if you have noticed, I have used break statement inside individual cases. Here this break statement exits the switch statement once the matching case is executed. If we don't use the break statement, all the cases after the matching case will be executed. Now let me show you. I'll remove this break statement from the program. So let's remove this. Now I have removed the break statement from each cases. Now I'll run this code and I'll enter 5 and it matches the case number 5, and Thursday is printed at first, then all the cases after that is also executed. So we get the output Thursday, Friday, Saturday, invalid number. This is why it is important to use break after every cases.
If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box.
We learned that using break after every case is important. However, sometimes there might be situations where we want to execute multiple cases together. In such situation, we can omit break statement. Let's see an example. As you can see, I have pasted some new code on the compiler. Here we want to check if the day is weekday or a weekend. So all the cases from 2 to 6 will print weekday, and the case 1 and case 7 will print weekend, and then the default will be an invalid number. Now let me run this code. I'll enter 4 here. As expected, we get weekday, and I'll run this again. This time I'll enter 1, and you can see weekend is printed on the screen. As you can see, we can omit the break statement as per our need. Next, we will use the switch case statement to create a simple calculator. Okay guys, we need your support to keep this type of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button, hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Now that we know the working of the switch statement, let's create a simple calculator using it. Here I have copy pasted the code from our GitHub repository so that you don't have to see me typing the whole thing. Now let's see what's happening in this code. Here we have created a character variable. We then ask the user to choose an operator and store the input in the operator variable. Then we ask the user to provide 2 input values and store them in num1 and num2 variable. Then the result variable will store the value after calculation. You can see we have used operator variable inside the switch statement, and each case statement uses an operator as its value. And based on this operator, the corresponding operation is performed inside the case. Now let me run this code. Here I'll enter plus, and I'll enter first number 8 and then second number 12. You can see I get 20 as output. What happens here is I provide plus as operator, and this plus operator matches with this case. Hence the addition operation inside the case is executed, and the final result is 8 plus 12, that is 20. The break statement then terminates the switch statement. Now let me run this code again. This time I'll enter asterisk and the first number 9 and the second number 5. Since I entered asterisk, the operator matched with this case. So the multiplication is performed between number 9 and 5, so we get 45 as our output. In this way, we can also perform subtraction and division. You can try it yourself. Now to revise what we have learned, here is a programming task for you. Use the switch statement to create a program that will find the month based on the number input. Here take the input from 1 to 12 and print the corresponding month based on the input value. If the number is 1, print January. If number is 2, print February, and number is 3, then print March, and so on. It's time for Programiz quiz. Which of the cases is executed in the following code? In this video, we'll learn about while loop to repeat a block of code for multiple times. We'll also learn about do while loop in C. Loops are used to repeat a block of code a certain number of times. Suppose we want to show a particular message 100 times. Instead of writing the same message 100 times, we can write the message once and use the loop to display the message 100 times. Let's start with the syntax of while loop. A while loop starts with the while keyword followed by the condition inside the parenthesis. Here the condition is a Boolean expression that returns either true or false. If the condition is true, then the statement inside the while loop are executed, then the condition is evaluated again, and if the condition is true again, then the statement inside the while loop is executed. This process continues and the while loop is executed on and on until the test condition becomes false. If the condition is false, then the while loop is terminated and the body of the loop is skipped. Let's see an example. I'll remove this old code, and by now you must be familiar with the basic structure of C program. So I'll write the basic structure of C program here. Now you can see the basic structure of C program. Now I'll create the while loop with the condition 1 is less than 5. And inside the while loop, I'll print the message while loop in C. So here the condition 1 is less than 5 is true, so the statement inside the while loop will be executed. Then the condition 1 is less than 5 is checked again. This time as well the condition is true, so the statement inside the loop will be executed again. Here 1 is always less than 5, so the condition is never false, hence the while loop will be executed infinitely until the memory runs out. This is called an infinite while loop. Now let's run this code. So you can see the statement while loop in C is printed until the memory runs out, and to avoid this infinite while loop, we need to make sure that our condition becomes false at some point. So I'll create an int variable count and assign value 1 to this. Now in the condition, instead of 1, I'll write here count. So the condition becomes count is less than 5. And inside the while loop, I'll increase the value of count by 1. So count equals to count plus 1. So this value of count will increase in each iteration. Now this line of code increases the value of count in each iteration, and ultimately the value of count becomes 5. So our condition becomes 5 is less than 5, which is false, and it will terminate our loop. So let's run this code. You can see the message while loop in C is printed 4 times. Let's see what's happening here. Initially the value of count is 1, so the condition count is less than 5 is true, so the text while loop in C is printed on the screen. Now the value of count becomes 2, and again the condition is evaluated. This time as well the condition is true, so again while loop in C is printed on the screen. Now the value of count is increased to 3. In this way the value of count keeps increasing in each iteration, and after the 4th iteration the value of count becomes 5. This time this condition count less than 5 becomes 5 is less than 5, which is false, so the loop terminates and hence the text is printed 4 times. We can also print the count variable to see the subsequent increment of count variable. Let me show you. Here inside the loop I'll add print statement and I'll print the value of count. So count equals %d, count. And we need to add here backspace n so that it will be printed on the different lines. So let's run this code. As you can see, the value of count is increasing in each iteration.
Now we know how the while loop works. Let's do something interesting. I'll create a multiplication table using the while loop. So I'll go to my code editor. As usual, you can see the basic structure of C program. Now I'll create a variable number. Now I'll ask the user to provide the input. So let's use printf statement, and I'll enter the message, enter the number for the users. So, and then I'll store the input in the number variable. So I'll use scanf statement. Just like before, I'll create a count variable. So count, and I will assign value 1 to this. I want to create a multiplication table up to 10, so I'll use while loop. So while with a condition count is less than or equals to 10. So inside the while loop, I'll multiply the number provided by the user. So number is multiplied with the count, and I'll assign this to an int variable, let's say product. Then I'll print this product variable. So using printf statement, we'll print this, and finally I'll increase the value of count by 1. So count equals to count plus 1. So before I run this, I'll add here \n so that the output will be more clearer. So let's run this program, and I want the multiplication of 8, so I'll enter 8, and you can see the multiplication of 8 is printed on the screen. Now let's see what's happening here. Inside loop, I'm multiplying the number provided by the user to the value of count. Then we are printing the value of product, and you can see the output on the screen, and then the value of count is increased in each iteration. Initially, the value of count is equals to 1. When the number 8 is multiplied with the value of count 1, the output is 8. And in the second iteration, the value of count is equals to 2. So 8 into 2 is equals to 16. In this way, the number is multiplied by the value up to 10. So we get the multiplication up to 10. Here I am printing only the product, and to be honest, it does not look like multiplication table. So I want to print the exact multiplication table, like 8 multiplied by 1 is equals to 8, and 8 multiplied by 2 is equals to 16, and so on. Now I'll modify my code. So I'll do %d into %d equals to %d. That is number into count is equals to product. Here you can see I am printing all these 3 variables with proper formatting. Now let me run this code, and I'll enter 8 again. As you can see, the output looks better now. Now you can create multiplication table of any number. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button, hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. In C programming, there is another version of while loop known as do while loop. The working of do while loop is similar to that of while loop with one major difference. Before we learn more, let's start with the syntax of do while loop. The do while loop starts with the do keyword followed by the body of the loop and the while keyword with the condition inside the parenthesis, and do not forget to put this semicolon at the end. Here the body of the loop is executed first and then the condition is evaluated. If the condition is evaluated to true, the body of the loop is executed again. This process continues until the condition becomes false, and if the condition is false, then the loop terminates. Let's see an example. So I'll remove this old code and I'll start with the basic structure of C program. As you can see, this is the basic structure of C program. Now I'll create a count variable. So count variable and assign value 1 to this. Then I'll write a do block and I'll print the value of count here. So %d and backspace n and count here. I'll increase the value of count by 1. Count equals to count plus 1. Now I'll use the while condition and I'll check if count is less than 5. Now let's run this code. As you can see, the value of count is increased in each iteration. When you compare a do-while loop with a while loop, you can see in the do-while loop, the code that is to be executed is kept inside the do block and the condition is checked. This is why the code in do-while loop is executed once even if the condition is false. Let me show you. Here I'll change the value of count from 1 to 5. Now the condition is 5 less than 5, which is false. So let me run this code. Here you can see we get 5 as output even after the condition is false from the beginning. This is because first the do block is executed, which will print the value of count, so we get 5 as output. Then the condition is checked, which is false, so the loop terminates. The do-while loop is executed once, no matter what. This is the major difference between the while and do-while loop. Since the working of do-while loop is similar to that of while loop, we can use it to print a multiplication table. Go ahead and print the multiplication table like before using a do-while loop. Now to revise what we have learned, here is a programming task for you. Can you use the while loop to print the multiplication table for the given number, but this time you have to print the number from 10 to 1, so the output would be something like this. It's time for Programiz quiz. Which of the following causes an infinite loop? Hey guys, this is me Padma from Programiz and welcome back to this series on C programming. In this video, we'll learn about for loop to repeat a block of code for a specific number of times. In the last video, we learned about while loop. Similar to the while loop, we can also use for loop to repeat a block of code for multiple times. Let's start with the syntax of for loop. A for loop starts with the for keyword and 3 expressions inside the parentheses. The first expression is called initialization expression. It declares and initializes a variable, for example, int I equals to 0. The initialization expression is executed only once. Next, the test expression. The test expression is a Boolean expression that evaluates to true or false. For example, I is less than 5. If the test expression is true, then the code inside the for loop is executed and then the update expression is executed. The update expression changes the value of a variable, for example, I++ or I plus 1. Here the value of I is increased by 1 in each iteration. Now again the test expression is executed. If the test expression is true again, then the code inside the for loop is executed and the value of I is updated again. And the test expression is evaluated for the third time. This process continues until the test expression I less than 5 becomes false. If the test expression is false, then the for loop terminates. Now you know the working of a for loop. Let's see an example. I'll remove this old code and I'll start with the basic structure of C program. Here you can see the basic structure of C program. Suppose I want to print the number from 0 to 9. So I'll use for loop with initialization expression int I equals 0. Since I want numbers up to 9, so I'll write the condition I less than 10. And I'll increase the value of I by 1 in each iteration. And inside for loop, I'll print the value of I. So printf %d comma I. And to make our code much more cleaner and understandable, I'll put the space here. So I'll run this code. You can see the numbers from 0 to 9 are printed on the screen. Let's see what's happening here. Initially, the value of I is equals to 0. So the statement inside the for loop is executed and 0 is printed on the screen. Now the update expression increases the value of I from 0 to 1 and test expression is evaluated again. Since 1 is still less than 10, then the test expression is true and the statement inside the for loop is executed and 1 is printed on the screen. The update expression again increases the value of I from 1 to 2. The process continues for the value of I up to 9. When the value of I becomes 10, the test expression becomes 10 is less than 10, which is false. Then the loop terminates, and in this way we get the output from 0 to 9. We can also use the for loop to print the message multiple times. Here, instead of printing the value of I, I'll print the message. So I'll cut this part and I'll write the message like emergency condition. So let's run this. As you can see, the message emergency condition is printed 10 times. Now suppose I want to print the message 20 times. So I'll change the value from 10 to 20 and I'll run this again. As you can see, it is printed 20 times.
If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box.
Now, let's see a practical example of a for loop in C programming. Suppose we want to find the sum of all numbers from 1 to 100. Then instead of adding the number like 1 plus 2 plus 3 plus 4 and so on, we can do is use a for loop. Let me show you. I'll use the same code from earlier. First, I'll cut this part because we won't need this. Now I'll continue with the same code. Now since I want the sum from 1 to 100, so I'll change the initial value of I from 0 to 1 and I'll change this test condition from I is less than 20 to I is less than or equals to 100. Then this update expression will update the value by 1 in each iteration. Now our loop runs 100 times from 1 to 100. To store the sum of all numbers, I'll first create a variable sum and I'll assign value 0 to this. Then inside the for loop, I'll add sum variable with value of I. So sum equals to sum plus I. So it becomes sum plus 1 in first iteration and sum plus 2 in second iteration and so on. And finally, I'll print the value of sum outside the loop. So printf %d sum. Now I'll run this code. As you can see, we get 5050 as our output, which is the sum of all numbers from 1 to 100. Let's see how this program runs. Initially, the value of I is equals to 1. So this condition I less than or equals to 100 becomes true and the statement inside the loop is executed. Here we are adding sum with the value of I and assigning the value back to sum. So the new value of sum is 0 plus 1, that is equals to 1. Now the update expression will change the value of I to 2. Here the test expression is true again, and this time sum is equals to sum plus I, that is the value of sum is 1 from the first iteration and the value of I is 2 from the update expression. So 1 plus 2 is equals to 3. This time the value of sum is equals to 3. In this way, in each iteration, the value of I is added to the new value of sum, and finally when the value of I becomes 101, the test expression becomes false. So the loop terminates, and now final value of sum is equals to 5050, which is the sum of all the numbers from 1 to 100. You can see the use of for loop has made our tasks much easier and faster. If you have to add the number manually one by one, it will be so difficult and error prone. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button, hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Let's see one more example. This time I'll find the sum of only even numbers from 1 to 100. For this, all I have to do is change the initial value of I from 1 to 2, and I'll change this update expression by 2 instead of 1. So I'll change this. So I equals to I plus 2. So before I explain what's happening here, let me run this code. As you can see, the output 2550 is printed on the screen. Let's see what's happening here. Initially, the value of I is equals to 2, which is an even number. When the loop executes, 2 is added to the value of sum, which is 0, so the value of sum is equals to 2. Now, this update expression increases the value of I by 2, so the new value of I becomes 4, which is also an even. Since the test condition is true, then the expression inside the for loop is executed, so the value of I, which is equals to 4, is added with the value of sum, which is equals to 2 from the first iteration. So we get the value of sum equals to 2 plus 4, that is equals to 6, which is also an even number. In this way, the update expression only updates the value of I to an even number, and even value is added to the sum, and this way we get the sum of even numbers and we get the final output 2550. Now to revise what we have learned, here is a programming task for you. Can you use the for loop to compute the sum of only odd number from 1 to 100? In each iteration, you need to add an odd number to the sum. It's time for Programiz quiz. In the for loop below, which is the update statement? In this video, we'll learn about break and continue statement to alter the normal flow of loops in C programming. The break statement immediately terminates the loop when it is encountered. Before we move forward, let's see the working of loop first. Here I have used for loop. The loop starts from I is equals to 1 to I is equals to 5, and it prints the value of I. So let me run this code. As you can see, we get the output from 1 to 5. Now let me use break statement inside the loop after the print statement, and I'll run this code. This time I only get 1 as output. Let's see what happened here. During the first iteration, the value of I is equals to 1. So when the loop runs, the value 1 is printed. Now after the print statement, the break statement is encountered, and this break statement immediately terminates the loop. For more clarity, let me add another print statement after this break statement. So printf, and I'll enter the message after the break. So let's run this. As you can see, we get the same output 1. This is because when the break statement is encountered, the loop exits and no other code of the for loop is executed. We generally use the break statement with the decision making statement like if-else statement. This is why we can break a loop under a certain condition. Let's see an example. I'll use the same code from earlier. Here I'll remove this break statement and the print statement after that. Now suppose I want to end the loop when the value of I is equals to 3. So I'll add if statement. So if statement with the condition I is equals to 3, and inside this if statement I'll use break. Now I'll run this code. As you can see, we get the output 1 and 2. Here during the first iteration, the value of I is equals to 1. So this if statement is false. So we'll go to this print statement and 1 is printed on the screen. Now the value of I is increased to 2, and this statement is again false because the condition does not meet, and again this print statement is executed and 2 is printed on the screen. When the value of I is equals to 3, the if condition is true,
and this break statement is executed and the loop terminates. Hence we get the output 1 and 2. Let's now use the break statement with while loop. I'll create a program that will ask input values from the user. If the user inputs a positive value, it will be printed. However, if the user input a negative value, the while loop is terminated. I'll use the same code from earlier. I'll remove this for loop. I'll create a while loop that is always true. And I'll use 1 as a condition of while loop because we know that 1 represents true in C programming. So this while loop is always true. Now inside while loop, I'll declare a variable number. So int number, and I'll ask the input from the user, and I'll ask the user to enter a number, and I'll store it using scanf function. Since I want to break the loop only if the input value is negative, I'll add if statement with the condition number is less than 0, then we'll break the loop. And if it is not negative, we'll print the value of the variable. So I'll use printf statement, so %d and name of the variable, that is number. Now let me run this code and I'll enter 5. You can see 5 is printed, and I'll enter 9 and it is also printed. So now let's enter some negative value. You can see the loop terminated. Here you can see as long as we entered positive value, the while loop executed repeatedly. However, when the input is negative, then the if statement becomes true and the break statement is executed and it terminates the loop. Now let's move to the continue statement. Unlike break, the continue statement skips the current iteration of the loop and starts the loop with the next iteration. Let's see an example. In this code, we have used break statement to terminate the loop when the value of I is equals to 3. Now let me replace this break statement with continue statement. So continue, and I'll run this code. Now if you look into the output, you can see the value 3 is not printed. Let's see why this happens. We know that the loop runs for 5 times from I is equals to 1 to I is equals to 5, and during the first and second iteration, the value of I are 1 and 2 respectively, so if condition is false for both iteration. Hence, the loop runs normally and 1 and 2 are printed. During the third iteration, the value of I is equals to 3. This time, if condition is true and continue statement is executed. Now the continue statement skips the current iteration of the loop and starts the next iteration. So the program jumps to this update expression and increase the value of I to 4, and again for the value 4 and 5, the if condition is false and loop runs normally and 4 and 5 is printed on the screen. In this way, for value 3, the continue statement skips the print statement. Okay guys, we need your support to keep these type of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. We now know the working of break and continue. Let's use them together in a single loop. I'll create a program that takes the input values from the user. However, I want the user to input positive number only. So if the user enters 0 or a negative number, I'll use the break statement to terminate the loop. Also, to make the program more interesting, I'll only print the even numbers. So if the user inputs an odd number, I'll use the continue statement to skip the loop so that odd numbers are not printed. Let's start now. Here the break statement is already implemented that ends the loop if the number is a negative number. Since we want to exit the loop if the number is either negative or 0, I'll change this less than operator to less than or equal to operator. Now I want to run the continue statement if the number is odd. So I'll add if statement with the condition number modulo 2 is not equal to 0. So inside if we'll add continuous statement. Here the modulo operator returns a remainder. So for a number to be odd, it shouldn't have a remainder 0 when it is divided by 2. So let's run this code. I'll enter 4. You can see 4 is printed because it is an even number. Now I'll add 7 and I'll enter even number 32, and you can see this 32 is also printed. Now let's enter a negative value. So -3. You can see the loop is terminated. So as you can see, when the input value is positive and odd number, this condition becomes true, so the continuous statement skips the print statement for the odd input value. However, when the input values are positive even numbers, both the condition becomes false, so it is printed when it is an even number. When the input value is negative, this condition number less than or equals to 0 becomes true, so the break statement terminates the loop. Now to revise what we have learned, here is a programming task for you. Can you write a program that takes an input from the user and print it if the value is a negative odd number? However, if the input value is positive, in the loop with the message positive value, and if the input value is negative even, skip the value with the message negative even. So our output will look like this. It's time for Programiz quiz. Which of the following keyword is used to skip the current iteration of a loop? In this video, we'll learn about functions to divide our program into small blocks of code. We'll also learn different types of function available in C programming. A function is a group of related statements that perform a specific task. They help us divide a large program into smaller chunks so that it is easier to understand and modify them. Suppose you need to create a program that draws a circle and a rectangle of different colors based on user input. Instead of creating one big chunk of statement, to create this program, we can create 3 functions. A function to create a circle, function to create a rectangle, and a function to color the shape. Doing this helps us divide the complexity of the program and help us focus on the specific part of the program at a time. Now that you know why we need a function, let's see how we can create a function in C programming. On your screen, you can see the syntax of the function. Here the return type indicates the data type of the value that is returned by this function name. The function name is the name of the function, and this dot inside the curly braces indicates the statement inside the function. Now let's use this syntax and create a simple function that prints good morning. Here you can see the basic structure of C program. Now I'll start with the return type first. So here I don't want to return any value from the function, so I'll use void as the return type. Remember that if a function does not return any value, use the void as a return type. Now I will write greet as the name of my function, and don't forget to use the parentheses. These are needed to denote that this is a function. Now inside the function, I'll print good morning. So good morning. Now let me run this code. As you can see, nothing happened. This is because to run a function, we need to call it. Now to call a function, we use function name with the parenthesis. So we use the name of the function, that is greet, with the parenthesis. And I'll run this code. Now this time you see the output good morning. Let's see how this program works. Like any other C program, the execution starts from main, and when it encounters the function call, the control of the program moves to the function definition. Now the code inside the function is executed and good morning is printed on the screen. Once the execution of function is completed, the program of the control moves back to the next line after the function call. Now to verify this, we can print the statement after the function call. So I'll print after function call, and
Before I run this, I'll add here backspace n. Now let's run this. As you can see, first the code inside the function is executed. Now the control move back to the function call. So the code after the function call is executed. So we get the output good morning and after function call. And as discussed earlier, one of the good thing about the function is code reusability. Now once we create a function, we can reuse it any number of times. All we need to do is call it whenever we need. Now let me show you. I'll remove this print statement and I'll add greet 2 more times. So greet, and I'll run this. So this time you can see good morning is printed 3 times. Before we move to the next section, here is a quick tip for you. It is a good practice to use descriptive names for functions so that anyone reading the code will know what the function is doing by just reading the function name. Here we are greeting good morning, so we are using greet as its function name. We can also use wish morning or any other descriptive function name.
If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box.
So far, we have created function that just prints message. However, sometimes we might want to create function that accepts some value and performs some action based on that value. For example, suppose we want to create a function that accepts a number and computes the square of the number and print it. We can do this in C programming with the help of function parameters. A parameter is a value accepted by the function. Now let me show you how we can create function with a parameter. So let me get back to my previous code. I'll remove this greet function and I'll also remove this function call. Now I'll add another function, call it calculate square. So calculate square, and inside parentheses I'll add function parameter int number. Now inside the function I'll do int square is equals to number multiplied by number. Then I'll print the number and its square like printf bracket inside quotation square of %d is %d, that is after comma number comma square. Now here in the main function I'll call the function calculate square. Now let me run this code. Here we get an error. This is because when we create a function with a parameter, we need to pass the value while calling the function. So in the function call, I'll add 5 inside the parenthesis. Now I'll run this code again. This time you'll see the output. The square of 5 is 25. Now let me tell you what happened here. The calculate square function accepts the parameter, so we call the function by passing the value 5. Now the parameter number is assigned with the value 5. So when we use number inside the function, we are using the value 5. A function can also accept multiple parameters. Let's see an example. Here I'll change this function name from calculate square to add numbers. Inside the parenthesis, I'll change this number to int number 1, and I'll add comma, and I'll add int number 2. Now I'll remove these 2 lines inside the function and I'll add int sum is equals to number 1 plus number 2. And I'll add print statement after that to print the number and sum. So I'll do printf bracket inside quotation sum
of %d and %d is %d, that is number 1 comma number 2 comma sum. Now I'll remove this earlier function called calculate square and I'll add numbers with the value 8 and 9 as its arguments. So I'll run this. As you can see, we get the sum of 8 and 9, that is 17 as output. Here the value 8 and 9 are assigned to the parameter number 1 and number 2 respectively. In programming, values passed during the function call are also called function arguments. 8 and 9 in this case are the function arguments. Many people use parameters and arguments interchangeably, so don't worry about that. However, one thing you should remember is that the data type of parameter and argument should be the same. In our case, we have created int type parameters, so we pass integer values 8 and 9 during the function call. If we want our function to accept double or char type parameters, we should call the function with double or char values respectively. Go ahead and write a function that accepts double parameters and add them. Till now, we have been using void as the return type of our function. This is because our functions are not returning any value. In C programming, we can also create a function that returns a value. Suppose in our earlier program, instead of printing the sum inside the function, we want to return it. Let's see how we can do that. Here is the code from our earlier program. First, I'll remove this void and I'll add int. I'm using int because I want to return the sum of two numbers and the data type of sum is int. Now I'll remove this print statement and I'll add return sum. Here the return statement that is used to return any value from the function. Since the function is returning some value, this return value need to be stored somewhere. So during the function call, I'll assign the function call to an int variable, say result. So int result is equals to this function. Then I'll print the result using print statement. So printf result is equals to %d comma result. Now let me run this code. As you can see, we get the result 17, which is 8 plus 9. Here the function add numbers, add two number, that is 8 and 9, and it returns the sum. The return value now replaces this function call. So this statement becomes int result is equals to returned value, which is 17. Hence we print the result and we get 17 as our output. The data type of the return value and the data type of the variable where the return value is stored should be the same. The return statement is the last statement of a function. When a return statement is encountered, the function exits. We can verify this by adding print statement after the return statement. So I'll add a print statement after the return statement and I'll write here after return statement. So I'll run this. You can see we get the same output. The print statement after the return statement is not executed. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button, hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. In C programming, a function prototype is a declaration of a function. It provides information about the function name, parameters, and return types. However, it does not include the body. Let's see an example. Here I have the code from our earlier program. If you have noticed, I have put the code of add number function after the main function. Now let me add the function prototype for this add number function, so I'll add int add numbers parenthesis int number 1 comma int number 2. As you can see, the function prototype includes the function name and return type and the parameters inside the parenthesis. Now let me run this code. As you can see, the program runs without any issue. In our program, we are calling the function before defining the function. In this type of situation, the function prototype provides information about the function to the compiler. Now during the function call, the compiler can now match the function call signature with the function prototype signature. If we are defining the function before function call, a function prototype is not needed. That's why we haven't included any function prototype in our earlier program. So far, we have been creating our own function. These types of function, we write the function definition ourselves, are called user-defined function. In C, there is another type of function called standard library function. They are built-in functions that are already defined in the library files, and we can directly use them in our program. For example, the printf function. The printf function is a standard library function that allows us to print the output. The printf function is defined inside the stdio.h header file. That's why we need to include the file using include stdio.h. Similarly, the sqrt is another standard library function that allows us to compute the square root of a number. Let me show you an example. Here you can see the basic C program. First, we need to include math.h header file because sqrt is defined inside the math.h header file. So I'll include math.h header file. Now inside main, I'll use sqrt function. The sqrt function returns the square root of number as a floating point value. So I'll write float result is equals to sqrt, and inside sqrt I'll write 25 and I'll end this with semicolon. Now I'll print this square root is %f comma result. Now I'll run this code. As you can see, we get 5 as output, which is the square root of 25. In all of our program, we have used main. If we look into the syntax of main, it looks similar to a function. This is because main is also a function in C programming. It is the first function that is executed by the compiler, so every C program should include a main function. Now to revise what we have learned so far, here is a programming task for you. Can you create a program that takes two numbers, perform the multiplication of two numbers, returns the result? It's time for Programiz quiz. What is the correct way to call the following function? In this video, we'll learn about variable scope. More specifically, we'll learn about local and global variable scope in C programming. A scope is a particular region in a program, and a variable scope determines which variable can be accessed from which region of a program. In C programming, there are two basic types of variable scopes. They are local variable scope and global variable scope. Let's start with the local scope first. To understand the local scope, let's see an example of a C function. In my code editor, you can see function add numbers. This function takes two parameters and it stores the sum in the result variable and it prints the result inside the function. Instead of printing the result inside the add number function, let's print it after the function call. So I'll paste it here. So I have moved this line from the add number function to this main function. I will run this code. You can see we get an error saying result undeclared. This is saying the result is appeared for the first time in the line 11. You might be wondering, how is that possible?
even though we have declared the result variable here inside the function? Well, this is where the concept of local variables comes in. Any variable that is declared inside the function is a local to it, meaning the result variable is local to the add number function. This reason is called local scope, and the result variable has no existence outside this scope. When the function ends, the local variables are destroyed. This is why we get an error when we try to use the result variable outside the local scope. Now, if you remember, we can solve this problem by returning result from the add number function. So I'll add return result and I'll change this void to int. Since the function now returns a value, I will now assign this function to a variable sum, and then I'll print the sum. So I'll run this code. You can see the result is equals to 11, which is 5 plus 6. With the return statement, we are not using the local variables directly. Rather, we are returning its value to the function call and assigning it to another variable inside the main function. This concept of local variable is a good thing because anyone using this add number function does not need to know what's inside it. They just need to know what argument to pass and what value it returns, and they can use this function without a problem. This makes our code reusable to not only us but also to our fellow programmers. Another way we can solve our earlier program is using global variables. Global variables are variables that are declared outside of the function. Let me show you. So I'll use this code from earlier. As you already know, this code will generate an error. So now what I will do is I'll declare an int variable result outside the add number function. And then I'll remove this int from here. Now I'll run this code. As you can see, this code runs without any error. So what happened here is the result variable is declared in global scope. This is why we are able to access it from both the function, this add number function and the main function. It's time for Programiz quiz. In the following code, which variable is a global variable? In the last video, we learned to create a function. These functions, which we define ourselves, are called user-defined function. In C, there is another type of function called standard library function. The function definition of standard library function is already provided by C, and we can directly use them in our program. Let's see a simple example to print a text. You can see this code in my code editor. I'll run this program and you can see hello world is printed on the screen. Here printf is a standard library function that prints the text on the screen. We haven't provided any definition for printf. Instead, we are directly using it in our program. In C programming, a standard library function is a predefined function which is already defined inside a file, and we can directly use them in our program. In our case, the definition of printf file is present inside the stdio.h header file. That's why we have included stdio.h header file inside our program. And once the file is included, we are able to use the printf function inside our program. And also the scanf function that we have used to take the input from the user is also a standard library function, and it is also defined inside the stdio.h header file. There are various header files available in C programming. This file includes different standard library functions that we can use directly in our program. Let's learn about some of the C library files and standard library function present in those files. We'll start with the math file. The math.h file provides us with various built-in functions that helps us to perform mathematical operation easily. For example, the sqrt function computes the square root of a number. All these math-based standard library functions are defined inside the math.h header file. So to use them, we import the math.h header file in our program. Let's now use this math-based library function in our program. I'll start with the square root function. On your screen, you can see the basic structure of a C program. Now, first I'll import the math.h header file. So I'll include math.h header file.
Then I'll create an int variable, say num, and I'll assign value 25 to this. I'll print the square root of this number, so I'll write printf bracket inside quotation square root %lf and comma sqrt inside parenthesis name of our variable num. Here the sqrt function returns the value in double, so I have used %lf to print the output. Now let me run this code. As you can see, we get 5 as output, which is the square root of 25. Here we don't have to worry about the definition of sqrt function. We can simply pass a number and get the square root of that number. Similarly, we can use the cbrt function to compute the cube root of a number. Let me show you. I'll change the value of 25 to 27 and I'll change this function sqrt to cbrt, and then I'll change this text from square root to cube root. So I'll run this. As you can see, I get 3 as output, which is the cube root of 27. Now let me show you one more example. This time I'll calculate the power of a number. I'll use the same code from earlier and I'll remove these lines and I'll create two variables. So int a, and I'll assign value 5 to this int variable a, and another variable b, and I'll assign 2 to this. Now I'll use POW function. So inside the parenthesis I'll use two variables a and b. Here this POW function is the power function. I'll assign this to a double variable result. So double result is equals to POW function. And finally I'll print this using printf statement. So power %lf comma result, and I'll run this code. Here we get 25 as our output. So what happens here is this first argument a of the power function is the base value and the second argument b is a power raised to the base. So it gives 5 raised to the power 2, which is equals to 25. Now let me change this value of b from 2 to 3 and I'll run this again, and this time you can see we get 125, which is 5 raised to 3. There are various functions defined inside the math.h header file. You can learn about them on programiz.com website. I'll put the link in the video description below. Now let's learn about different library functions available inside the ctype.h header file. This file provides function to perform various operations on characters, hence it is known as a character type header file. Let's see some example. So you can see this basic structure of C program here. First I'll import ctype header file in our program. So ctype.h header file. Now inside the main function I'll create a character variable, say alpha, and I'll assign a character e to this. Let's first use a function to convert this character to uppercase. So I'll use a function to upper, and inside the parenthesis I'll use alpha, and I'll assign this to a char variable upper. So char upper is equals to this function. Then I'll print this using printf statement. So %c comma upper. I will run this code and you can see we get capital E as output. Now let's change this uppercase value to lowercase. So after this print statement, I'll write char lower and I'll assign function to lower, inside parenthesis I'll put here upper. Then I'll print this lower variable as well. So %c comma lower, and
and then I'll run this code. As you can see, the capital E is now converted to lowercase e. In our example, to upper and to lower are standard library functions that are used to convert character to uppercase and lowercase respectively. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button, hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Now that we know how to use library function in our program, let's see why standard library functions are so helpful. As we saw earlier, we can directly use library function in our program. We don't have to worry about the function definition and we don't have to write the code ourselves. This saves significant amount of time, and since they are already tested, they work completely fine without any error. Also, they are built inside the C program, so they are optimized for better performance and developers are constantly improving to keep them up to date. There are so many library functions in C programming. If you want to learn about them, visit our text-based tutorial. I'll put the link in the video description below. Now to revise what we have learned in this video, here is a programming task for you. Create a program that computes the result of a number raised to the power of the square root of a number. So, first take the input from user, compute the square root of number using sqrt function, compute the power of the number raised to the power of its square root, and then print the result. It's time for Programiz quiz. What is the correct way to include library function in our program? In our past videos, we'll learn about function. Now we will learn to create a different type of function that call itself. These are called recursive function. In computer programming, recursion is a process that allows us to create a function that call itself. Let me show you what does that mean. On your screen, you can see we have created a function named recurse, and you can also see we are calling the recurse function from inside its body. Here the function is calling itself. This is called a recursive function. Let me tell you how this works. Initially, the recurse function is called from the main function. Now the control of the program goes inside the body of the recurse function. Inside the function body, we have included the function call to call the same recurse function. Now again, the program's control move back to the recurse. In this way, the function is called again and again. This might result in infinite function execution. To prevent this infinite recursive call, we need to provide an if-else statement. Let me show you. You can see we have put the recursive call inside if-else statement. Now the function call itself only under certain condition. This way we can prevent the infinite recursive call.
If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box.
Now that we know how recursion works, let's see an example. I'll create a program that computes the sum of n natural numbers. Instead of typing the program line by line, I'll just copy the program so that I can focus more on the actual working. In our previous video of function, we have already discussed about this function prototype. So if you want to know more on this, you can find the link in the video description as well. Here we have sum function that takes in parameter n. Here n represents the number up to which we have to find the sum. For example, if n is 4, we have to find the sum of 4 numbers 1, 2, 3 and 4. Inside the sum function, we have an if-else statement that checks if n is equals to 0. If false, the function makes a recursive call to itself. However, for each recursive call, we are decreasing the value of n. And finally, when the value of n becomes 0, the else condition returns n and the recursive call is stopped. Let's run this code and I'll enter 4. You can see we get the sum is equals to 10. Let's see how it works. So initially we provide 4 as input value. which is stored inside the number variable. This value is passed to the sum function during the function call from the main function. Inside the sum function, the value of n is now 4, so the condition is not equal to 0. So this condition becomes true and if statement is executed. Here the return statement inside if returns n, which is 4, plus a recursive call to sum with a new value 3, which is 4 minus 1. Now again the value of n is 3, which is not equals to 0. So this condition is true again, so the if statement is executed. Now if statement returns 3 and a function call with a new value 2. This process continues until the value of n becomes 0. When n becomes 0, the else statement is executed, which returns 0. Finally, we have returned value 4 plus 3 plus 2 plus 1 plus 0, hence we get 10 as output. Also, this image will help you visualize the working more clearly. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button, hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Now to revise what we have learned in this video, here is the programming task for you. Create a program that computes the factorial of a number. Here, take an input number from the user, create a function that takes the number as a parameter. Inside the function, check if the number is greater than 0. If true, return number multiplied by a recursive call to the function with parameter 1 less than number, else return 1. It's time for Programiz quiz. Which of the following statement is false? In this video, we'll learn about arrays in C. So far, we have been using single variables to store a single data. Now we will learn to store multiple data together inside a single variable using an array. An array is a collection of similar type of data. Before we learn about array in C, let's first know why we need them. Suppose you need to store the age of 100 people. One way to solve this is to create hundreds of variables to store the age of each individual. However, that will be a lengthy and tedious task. Instead, what we can do is create a single array and store the age of 100 people together. You got that right? Now let's see how we can declare an array in C programming. On your screen, you can see the syntax for array declaration. Here, data type means the type of data that will be stored inside the array. For example, if data type is int, all the elements will be of int type. Array name is an identifier that will be used to identify the array, and array size specifies the number of elements that can be stored inside the array. Let's see an example. I'll type int because I want to store integer data, and I'll call my array is, and since I want to store the age of 5 people, I have written 5 inside the square bracket. In the C programming, we cannot change the size and the data type of an array once it is declared. So now the data type of age will be int and it can only store 5 values. Now that we know how to create an array, let's learn to store data in it. I'll go back to my code editor. Here you can see the code from earlier. I don't need the syntax anymore, so I'll just remove this. So now let's continue with this code. Similar to assigning values to a variable, we use equal to operator to assign data to an array. Now I'll assign 5 values: 21, 29, 25, 32 and 17. These values inside the curly brackets are called array elements. We can also omit the size of the array. For that, I'll remove this. In this case, the C compiler automatically determines the size of the array by counting the number of elements inside the curly bracket. Another thing we can do is assign less number of elements than the declared length. For example, here I'll add 5 inside the square bracket and I'll remove these 2 elements from the curly bracket. You can see the length of array is 5. However, we are assigning only 3 values to this. Here the remaining 2 positions are filled with the default value. In our case, the 4th and 5th position will be 0. Now we know how to assign value to an array. Let's learn to access them. But first, let's learn about the array index. In C programming, each element of array is associated with a number. This number specifies the position of an array element inside an array and is known as array index. An array index starts with 0, so the first element of the array is present at index 0. Similarly, the second element is present at 1 and so on. We use the array index to access array element. Let me show you. Here we have our array from our earlier program. Now let me complete this program. So hash include stdio.h int main, and inside the curly bracket return 0. This is the basic structure of C program, so I'll cut this and put it here. Now to access an array element, we use the array name and the array index inside the square bracket. So to access the first element of this array, we use is square bracket 0. Let me use this and print the first element. So %d comma is square bracket with the index 0, and I'll run this. As you can see, 21 is printed on the screen. Similarly, we can access second, third, fourth and fifth element by using array indices 1, 2, 3 and 4 respectively. Now what I'll do is I'll copy this and I'll paste it here, and I'll change the index value from 0 to 1, 2, 3 and 4, and I'll run this. Here you can see all elements are accessed. Earlier we learned to assign multiple values to an array during the declaration. We can also assign values individually using the index number. Let's see how we can do that. On your screen you can see the earlier code. Here we have assigned all 5 values during the declaration. Since I want to assign values individually, I'll remove this assignment. Now I can assign values individually using the index number. So to assign the first value, I can write is square bracket inside the bracket 0 index is equals to 21. Similarly, I can assign a second value at the index 1. So is inside the bracket 1, and I'll assign value 29 to this. In this way, each value can be assigned to a particular index. So I'll continue on this. I'll run this code. As you can see, each value is assigned to the array. Here this acts as a variable, so we can take input from the user and assign to it. Let's see an example. I'll remove these assignments. Now I'll ask the user for 5 input value. So I'll use print statement and I'll ask the user to enter 5 input values, and I'll use scanf to store the input values. So scanf bracket inside quotation %d comma ampersand is square bracket inside the bracket 0 index, and scanf %d comma ampersand is square bracket inside the bracket 1. Here you can see I have used print statements to print the values. Now I'll run this code and I'll enter 21, 29, 25, 32 and 17. As you can see, the input values are now stored inside the array. We can also change the value of an array element. For this, we can simply assign a new value to a particular array index. Let's see an example. I'll use the same code from earlier. Here I'll remove these print statements. Now suppose I want to change this third value to 26.
from 25, here I can simply assign a new value to the position 2. So I will do is square bracket inside the bracket 2 is equals to 26, and I'll print this. So %d comma is square bracket inside the bracket 2, and I'll run this. You can see the value at index 2 is 26. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. In this example, we have used 5 different scanf statements to take 5 input values of an array. Also, we have used 5 different print statements to print values of the array. Here, instead of writing the same code again and again, I can simply use a loop. I can use one loop to take the input values and second loop to print the values. I'll first add a for loop. As we know, array index starts from 0, so int I is equals to 0. So we have started our loop from I is equals to 0, and since the array can store 5 elements, so I is less than 5, and we have this update expression that increases the value of I in each iteration by 1. Now inside the loop, I'll add scanf statement, and I'll use ampersand is with a square bracket inside the bracket we have I. Here you can see each input values is stored in a sequential index from 0 to 4. That's why inside the for loop we have used index I along with the is in the scanf statement. In each iteration of the loop, the value of I is increased by 1 and input value is stored sequentially. Now I can remove this message and these scanf statements. Similarly, I can use for loop to print the array elements. So for int I is equals to 0, I is less than 5, and now inside the for loop I'll use printf statement %d comma is with the square bracket inside the bracket I, and I'll remove these print statements. I'll run this program and I'll enter 21, 11, 14, 16 and 17. Here you can see we get the desired output. Let me show you something interesting. In this code, here I'll change the condition from I less than 5 to I less than 6, and I'll run this code and I'll enter 12, 13, 14, 15 and 16. You can see a random number. So what happens here? Well, we have created the array to store only 5 elements. Now we can access array elements from index 0 to index 4. However, our for loop runs from I is equals to 0 to 5. So when the value of I becomes 5, the element is square bracket 5 does not exist. As a result, we get an unexpected value. Sometimes we can also get an error due to this. So we should never try to access element of an array outside of its bound or length. Now to revise what we have learned in this video, here is a programming task for you. Create a program that computes the average marks of a student. For this, create an array that stores the marks of 5 subjects. Compute the total marks by adding all the marks, divide the total marks by total number to the subject and print the average marks. It's time for Programiz quiz. Which value will we get when we print num square bracket 4 from the following array? In this video, we will be learning about the multidimensional array, and we will also learn to write the matrix multiplication program in C programming. We learned that an array stores multiple elements together. Similarly, a multidimensional array also stores multiple elements.
The only difference is that each element of multidimensional array is also an array. This is why a multidimensional array is also known as an array of arrays. Let's start with the syntax of multidimensional array. Here the array is of int type, which means it can only store integer data, and ARR is the name of the array, and 2 and 3 represents the size of the array. Here 2 means there will be 2 arrays inside this array, and 3 means each array will have 3 elements. Now altogether our array can store 2 into 3, 6 elements. Now let's see how we can initialize a 2-dimensional array. I'll use this same array. Now I'll first assign values to this array. So this array is equals to curly bracket, inside this curly bracket another curly bracket with element 1, 3, 5, and enclosing this bracket and another comma here and curly bracket here. Here is 2, 4, 6. These are the elements of first array and these are the elements of second array. You might think that this assignment looks different than the assigning value to a single dimensional array. It's because here we are assigning arrays, not individual elements. We have assigned 2 arrays and these 2 arrays has 3 elements each. Here this is the example of 2-dimensional array. And we can think of this as a table with 2 rows and 3 columns, where rows represents arrays and column represents element inside the array.
If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box.
Now that you know how to store elements to a multidimensional array, let's learn to access them. Remember array indexes? Well, the concept of array indexes is also present in multidimensional array. However, here each element is associated with 2 indexes. Let me explain this. I'll go back to my code editor. Here we have our earlier code. Now to access the first element, we use the array name and indexes 0 and 0. So array name with indexes 0 and 0. Here this first 0 indicates the first element of our array, which is this array, and the second 0 indicates the first element of the first inner array, which is 1. Similarly, to access the third element of second array, we write ARR with index 1 and another index 2. Here this 1 represents the second array and this 2 represents the third element of the second array. Now let's complete this program. So I'll start from the basic structure of C program. I will now cut this part and I'll paste it here. And I'll print this both arrays, so I'll use printf statement, comma, I'll cut this and I'll paste it here, and I'll do the same for this array as well. I will now run this code. As you can see, we get 1 using this ARR 00 and we get 6 using this ARR 12. To get the idea of indexes in multidimensional arrays, you can refer to this image. We can also change the elements of a multidimensional array by using array indexes. Let's see an example. Here we have the code from our earlier program. I'll remove these 2 printf statements from here. Now suppose I want to change this value of 5 to 7 and the value of 4 to 8. Here the value 5 is a third element of first array. So we can use the index 0 and 2. So we'll write ARR with index 0 and 2, and I'll assign value 7 to this. Similarly, 4 is a second element of second array, so we can use index 1 and 1, and I'll assign value 8 to this. I will now add print statement here and print these both arrays. So %d comma ARR with square bracket 0 and 2, and printf %d comma ARR second array and second element. I'll run this code. As you can see, the value at this position is changed from 5 to 7, and the value of this position is changed from 4 to 8. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe. If you haven't already, let's get the engagement score high up so that more people can discover and enjoy these courses. Similar to an array, we can also access each element of a multidimensional array using a for loop. Let me show you. Here in our earlier example, I'll remove these lines of code from here. Now I'll write two for loop. For bracket int I is equals to 0 and I is less than 2 plus I, this is the increment expression, and inside this for loop there is another for loop. Int j is equals to 0 and j is less than 2, sorry, j is less than 3, and we have increment expression. Here the for loop iterates 2 times from I is equals to 0 to I is equals to 1 to access the two inner arrays of two-dimensional array. And the inner for loop iterates 3 times from j is equals to 0 to j is equals to 2 to access the 3 elements of both the inner array. Now inside the inner for loop, I'll now print the element at index I and j. So printf bracket inside quotation %d comma ARR inside the square bracket I and j. I will now run this code. As you can see, the elements of multidimensional array are printed. Here the outer for loop runs 2 times from I is equals to 0 to I is equals to 1, and in each iteration of outer loop, the inner loop runs 3 times from j is equals to 0 to j is equals to 2. Initially, the value of I and j is equals to 0, so ARR ij prints the first element, that is 1. Now in the second iteration of the inner loop, the value of j is increased to 1 and the array ij becomes 0, 1, and it prints the second element 3 on the screen. In this way, the inner loop runs 3 times to access all 3 elements of first array. After that, the condition of inner loop becomes false, so the inner loop terminates. Now the program control moves back to the outer for loop and the value of I becomes 1, and again the inner loop restarts from j is equals to 0 to j is equals to 2. This time ARR ij becomes ARR 1 0, ARR 1 1 and ARR 1 2, which gives the first, second and third element of second array. To help you visualize the output more clearly, let me print a new line after the inner loop. So printf, I'll break the line here. I'll run this program and you can see the output is printed in proper format. It's time for Programiz quiz. Which value will we get when we print ARR 1 4 from the following array? In this video, we will be learning about strings in C. More specifically, we will be learning to use textual data in our code. Let's first see the example of the Hello World program. Here, Hello World is an example of a string. We have used double quotation to represent strings. In programming, strings are a collection of characters that are used to represent textual data. For example, Hello World is a string containing a sequence of characters H, E, L, L, O, W, O, R, L, D, world. Now that you know what strings are, let's see how we can create them in C. Here we have created a string type variable str with the value Programiz. If you look carefully, you can see the syntax of string looks somehow similar to an array. This is because the string in C are an array of characters. So this code is similar to this. So let's complete this program. Has include stdio.h int main, inside the curly braces return 0. I'll cut this and I'll put it here. Then I'll print this using printf statement. So %s, str. Here you can see we have used %s format specifier to print the string. Now let me run this code. You can see we have successfully printed the string. By the way, every string in C is terminated by a null character represented by /0. This null character helps the compiler to identify the end of the string. Even in our string Programiz, the compiler adds /0 at the end. Due to this, the actual size of the string will be 1 greater than the total number of characters in the string. We can use the same scanf function to take string input from the user. Let me show you. Here I have this code from earlier program. I'll remove this part. Now if you remember, this is the syntax of declaring an array. I'm declaring an array of characters, so I have to provide the size of this array as well. I'll add here 20. Now I'll add scanf statement to take the input from the user. You can see I have used str instead of %str. This is because str is an array and it already points to the address of the first element of str. Hence, we can omit ampersand, and we will discuss this in our later videos. Now before the scanf, let me print the statement and ask the user for their name. So printf, I'll enter your name here. Now I'll run this and I'll enter my name. You can see input value is stored on str string. Now let me run this code again. This time I'll enter my full name, Padma Manandar, and I'll enter. However, I'm only getting Padma instead of my full name, Padma Manandar. This is because the scanf method only takes the input until it encounters white space. Here there is a space after Padma, so the scanf method only takes Padma and ignores Manandar. If you want to take the entire line of string as input, we can use fgets function. Let me modify the program. I'll remove this scanf function and I'll add here fgets bracket str, size of str, stdin. Here fgets function only takes 3 parameters. The first parameter represents the name of the string. In our case, str is the name of the string, and the second parameter is size of the string, and this third parameter is stdin, which means standard input, which denotes that we are taking input from the keyboard. Now let me run this program. I'll again type my full name and I'll enter. This time you can see my full name is printed. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. We know that a string is an array of characters in C. So, just like an array, we can access each character of a string using indexes. Let's see an example. I'll start with the basic structure of C program. So, has include stdio.h int mean, and inside this curly braces return 0, and here I'll create string with value Programiz. So char str square bracket is equals to Programiz. Now to access the characters, we can use string name and the index inside the square bracket. So let's access the first character and print it using print statement. So I'll use print statement printf %c comma str and index is 0, and I'll run this code. You can see P is printed on the screen. Similarly, we can access other elements easily using array indices. For that, I'll copy this. So I'll copy this and paste it here, and I'll just change the value of index number here from 0 to 1, 2 and 3. So now second, third and fourth elements can be accessed using array indices 1, 2 and 3. So now let's run this code. As you can see, we get the desired characters. We can also change the character of a string. For this, we can simply assign a new character to a particular index. Let's see an example. I'll use the same code from earlier program. Here I'll remove these print statements. Now suppose I want to change this third character to capital O. I can simply assign value to index 2. So str square bracket will point to the index number 2 and will assign its value capital O. Now let's change this fifth character to capital R. So I'll do the same process here again. So str with the index number 4, that means the fifth element is equals to capital R. I'll now print the string using printf statements. So printf bracket %s comma str, and I'll run this program. As you can see, the third character is changed to capital O from small o, and the fifth character is changed from small r to capital R. To revise what we have learned so far, here is a programming task for you. Create a program that takes your full name as input and prints your name. Then change the first letter of your name to X. Now, if your name is John Williams, it will be X on Williams. If your name is Julie Bing, it will be Julie Bing with X as your first character. It's time for Programiz quiz. In this video, we will learn about 4 most important string functions that are used to perform different operations on string. Let's revise the working of string first. So I'll go back to my code editor. Here I have the basic outline of a C program. Now I'll create a string. Char language is equals to C programming. Let me print this string using printf statement. So printf bracket %s comma language. As discussed in our last video, we use %s to print the string. Now I'll run this code. As you can see, we have successfully printed the string. This is the basic understanding of how string works in C. If you have some doubts about this, I highly recommend you to watch our previous video. You can see the link on the screen. Now let's start with the string function. The strlen function or string length function is used to find the length of a string. Let's see an example. Here is the code from our earlier program. Suppose I want to find the length of this string. For that, I can use strlen function. But before that, we have to import string.h header file. So I'll include here, include string.h header file. This is important because strlen function is a standard library function that is defined inside the string.h header file. Now let's use the strlen function. I'll use printf statement here and backspace n length %getu comma strlen function and inside the function language. Here %getu is the format specifier that we use to print the return value of strlen function. Now let me run this code. Here you can see 13 as output. The strlen function counts the total number of characters in the string.
If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box.
The strcpy function or string copy function is used to copy one string to another. Let's see an example. Suppose I have a string named food and I'll assign value pizza to this. I want to copy this string to another string named best food. So let me first declare the best food string. So best food string, and inside the bracket I'll put strlen and bracket food. Here I have used strlen function so that the length of the best food string is same as the food string. Now let me use strcpy function and I'll copy the string from food to best food. So best food comma food. The strcpy function takes two values: source string from where we want to copy and the destination string, and I'll print the best food now. So using printf statement %s comma best food. Now I'll run this code. Here you can see the string is copied from the food to best food. The strcat function or string concatenation function is used to join two strings together. Let's see an example. Suppose we have two strings. Char text1 is equals to hey and char text2 is equals to, it has value how are you. Now let's use strcat function to join these string. So strcat bracket text1 comma text2. I'll print this using printf statement. So %s comma text1. Now I'll run this code. Here you can see two strings are joined together. However, the output does not look nice. So let me add here comma and a space, and I'll run this again. Now you can see a clear output that are concatenated together. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. The strcmp function or string comparison function is used to compare two strings. The function returns 0 if both the strings are equal. However, if the strings are not equal, it returns a random non-zero value. Let's see an example. Suppose we have two strings, char text1, and I'll assign value ABCD, and another string that is text2, and I'll assign here value EFGH. Now let's compare these two strings using strcmp function. So I'll use strcmp function bracket here text1 comma text2, and since this function returns an integer, I'll assign the return value to an integer. So int result is equals to strcmp function. Now I'll print this using printf statement %d because this time it gives us integer value, and here we will put result, the name of the variable. Now I'll run this code. Here we get -4 as output, which is a non-zero value because these two strings are not equal. Now let me change the value of this text2 from EFG to ABCD, and I'll run this again. This time we get 0 as output because here the both strings are equal. Apart from these four, there are dozens of string functions that can help us to work with string. However, remembering them is not possible. Instead, what you can do is Google and find the function that you need. Remember, Googling things is one of the most important skill in programming. Now to revise what you have learned in this program, here is a programming task for you. Create a program to compare two strings and print the larger string. Here is how the program should work. Get two string input from the user using fgets, compare the length of both the string using strlen, and print the larger string. It's time for Programiz quiz. Which of the following function is used to join two strings? In this video, we'll learn about pointers in C. More specifically, we'll learn to work directly with computer memory address with the help of pointers. Pointer is one of the main features that make C programming so powerful. It allows us to work directly with the computer memory. Before we learn about pointers, let's first learn about addresses. In C programming, whenever we declare a variable, a space will be allocated in the memory for the variable, and C allows us to access the address of the variable. We use the ampersand symbol with the variable name to access the memory address. Let's see an example. You might be familiar with the basic structure of C program. Now I'll create an integer variable is, so int is, and I'll assign value 25 to this. Now let's use ampersand symbol to access the address where the is variable is stored. So printf %p, comma, ampersand is. Here I have used %p format specifier to print the address. Now let me run this code. Here you can see we get this output, which is the memory address where 25 is located. When you copy and run the exact same code, you may get different output because the output is based on the location where the variable is stored, and it varies device to device. If you remember, we have used ampersand symbol with scanf like this, like ampersand is. So usually we use this ampersand is with scanf while taking input from the user. This is because with scanf, we are instructing the compiler to store the input value at the memory address specified by this %. Now that you know about memory addresses, let's get back to pointers. Just like a regular variable, a pointer is also a variable. However, a pointer variable stores the memory addresses of the variable, not the actual value. Let's now see how we can create pointers. So I'll create pointer int asterisk ptr. Here ptr is a pointer variable. Let me create a regular variable and compare these two. So I'll create int var. When comparing these two, you can see the only difference between these two is this asterisk symbol. Now let's see how we can assign value to a pointer variable. Here is our code from our earlier program. Now let me create a pointer variable int asterisk ptr. As we know, a pointer variable stores a memory address of a variable, and we also know that %s gives the memory address. So when we assign %s to the pointer variable should store the memory address of the a's variable. So let's do that. Now I'll assign this pointer to the address of a's variable, and I'll print this using printf statement. Ptr. Now let me run this code. Here you can see we get the same result for both %s and ptr. We can also access the value of a variable using the pointer. Let's see an example. In our code from our earlier example, I'll remove this print statement and I'll modify this print statement here, address colon backspace n. Now let's print the value using ptr pointer. I'll use printf statement printf value colon %d comma asterisk ptr. Here asterisk ptr gives the value stored in the ptr address, and since the value is an integer, I have used %d format specifier. Now let me run this code. As you can see, we have successfully accessed the value using the pointer variable. Remember, ptr is a pointer that stores the memory address, and asterisk ptr gives the value stored in the memory address pointed by this ptr. In our last example, we saw that we can access value of a variable using pointer variable. Similarly, we can also change the value of a variable using pointer variable. Let's see an example. Here we have our code from our earlier program. Here in this program, I'll remove these two print statements. Now let's use pointer variable to change the value from age 25 to 31. So I'll use pointer and assign value 31. Since we know asterisk ptr gives the value pointed by the ptr address, so this code assigns a new value to the memory address pointed by the ptr variable. Now let's print the value of the age variable. I'll use printf statement %d comma age, and I'll run this. Here you can see the value of age variable is changed to 31. This is because the ptr pointer points to the address of age variable, and we have changed the value pointed by ptr pointer from 25 to 31. So ultimately we have changed the value of the age variable. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. While working with pointers, you might encounter these two syntax of creating pointers. While both are the valid ways to create pointers, You should try to avoid the first one because this syntax sometimes creates a lot of confusion. Let's try to understand this with the help of an example. Here we have created a pointer that stores the memory address of the age variable. In this syntax, this asterisk symbol is attached to PTR, so many thinks that this asterisk PTR is the pointer and try to print the address using asterisk PTR, which is wrong. This is because asterisk PTR gives the value pointed by the pointer, not the memory address. Let me show you. I'll use printf statement here %d comma asterisk PTR and I'll run this. As you can see, we get the value of the age variable, not the memory address. So to avoid this confusion, I highly recommend you to create pointer like this. Now you can visualize PTR separately as pointer and asterisk as the part of syntax to create a pointer. Now let's revise pointers. Here we have a regular variable number and pointer PTR. Then PTR is equals to number is wrong. This is because PTR is pointer which can only store memory address, but number is not a memory address. So this is invalid. Asterisk PTR equals to ampersand number is also wrong. This is because asterisk PTR gives the value stored in the PTR location, however ampersand number gives the memory address. So this is also invalid. PTR equals to ampersand number is a valid code because both PTR and ampersand number represent the memory address. So this is a valid code and asterisk PTR is equals to number. This is also valid because both asterisk PTR and number represent the value stored in the memory location. So this is also a valid code. Now to revise what we have learned in this program, here is a programming task for you. Create a program to change the value of a variable using a pointer. Here is how the program should work. Get input value for a double variable salary, assign the address of salary to a double pointer. Now use the pointer to print the value of a salary and increase the salary by 2 times and print the new salary. It's time for Programiz quiz. Which of the following is valid for variable A and pointer P? In the last video, we learned about pointers in C. We learned about working with memory addresses. Now we will learn to use pointers to work with arrays. An array is the collection of similar type of data. You can see the example on the screen. Here, numbers is an array that stores 5 elements. And if we want to access these array elements, we can use the array index. That is, to access the first element, we use number bracket 0. Similarly, to access the second and third element, we use number bracket 1 and number bracket 2. In this way, we can access each element of the array. Now, let's try to access these elements using pointers. But first, let's try to access the memory address where these array elements are stored. So, here we have our array of numbers and we are printing the array elements using printf statement inside the for loop. Now let's print the address of each element using the ampersand operator. Let's modify this print statement. I'll add here %p and here comma ampersand numbers bracket I. I have used %p format specifier to print the memory address, and also I have used here ampersand number square bracket I to print the memory address of the ith element. Now let me run this code. As you can see, we get the corresponding address of each element. Now let's see something interesting. For that, I'll print the address of array without any array index. So I'll use printf statement, printf, here array address %p, comma, numbers. Now let me run this code. Here, if you look into the output, you will notice two things. First, the difference between two memory addresses is 4. This is because the array is of integer type and size is of int is 4 byte. Second, the memory address of the first array element and the address of the array is the same. This is because the address of array always points to the first element of the array. Also, here we have used only the name of the array without the ampersand sign. This is because in most contexts, array names are by default converted to pointers and we can directly use the name of the array. So from now on, if I use array name, remember it's the pointer. Similarly, we can use number plus 1 to print the address of the second array element, and we can use number plus 2 to print the address of third array element. Now let me show you that. So what I'll do is I'll copy this and I'll paste it here, and I'll modify this print statement to have a clear output. So array address of 1 backspace n, and I'll change this to numbers, then array address of 3, here I'll add here backspace n, and I'll change this to numbers plus 1, and I'll change this to array address of 5, and let's put this as it is. Now let me run this program. As you can see, this number gives the address of first element, and numbers plus 1 gives the address of second element, and numbers plus 2 gives the address of third element. In this way, numbers plus I gives the address of ith element. So we can implement this exact logic in a loop. So I'll modify this code. First, I'll remove this print statement, and in this print statement, I'll modify this ampersand numbers bracket I to number plus I. So number plus I. Now let me run this code. As you can see, we get the desired output. In our last example, we saw that for an array numbers is a pointer that gives the array of the first element. Similarly, numbers plus I gives the address of the ith element. Now we can use this pointer to access the array elements. To access the first element, we can use asterisk number. Similarly, to access the ith element, we can use asterisk parenthesis numbers plus I. Let me show you. You can see the code from our earlier program. Here, numbers plus I gives the address of the ith element. Since I want to use the pointer to access the element, I'll remove this number bracket I from here. Instead, I'll write asterisk parenthesis numbers plus I. So this gives us the ith element. Now let me run this code. As you can see, number plus I gives the address of the ith element, and asterisk parenthesis number plus I gives the value present at that number plus I address. In this way, we are able to access the address and value of an array using pointers. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button, hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Just like accessing the array elements, we can also change array elements using pointers. All we have to do is assign a new value to the address. Let me show you. Here I have the code from our earlier program. I'll remove this for loop. Now suppose I want to change the value of first element to 2. So I can simply write here asterisk numbers is equals to 2. Here asterisk number represents the first element, and I have assigned a new value to it. Also, let's change the last value to 11 from 9 so that our array includes only prime number. So I'll write here asterisk parenthesis numbers plus here 0, 1, 2, 3, 4. So numbers plus 4 is equals to 11. Here asterisk parenthesis numbers plus 4 represents the last element, and I have assigned a new value to this address. Now to verify the value are changed or not, let me print the first and last value. So I'll use print statement. Here first element is %d backspace n comma asterisk number, and another print statement. Here it prints the last element. Here last element colon %d comma asterisk parenthesis numbers plus 4. Now let me run this code. As you can see, the value of first and last elements are changed. Now to revise what you have learned in this program, here is a programming task for you. Create a program to find the largest element of an array. First, create an array with elements 34, 12, 21, 54 and 48. Then assign the first element to the array to a largest variable. This time you should use a pointer instead. Run a loop to iterate through each array element. In each iteration of the loop, compare the largest variable with each element of the array using a pointer. And if the largest element is smaller than the array element, assign the array element to the largest variable, again using pointers. Finally, print the largest variable. It's time for Programiz quiz. In an array, int ages bracket 5, what does ages represent? In the last few videos, we have been learning about pointers in C. We'll continue that in this video as well. Today we will learn to use pointers and function together. This is going to be an interesting video. Let's revise the working of the function with the help of an example. Here I have created a function that calculates the square of a number. The function takes single parameter and it then computes the square of the number and then returns the square. Here we are passing a regular variable to the function. In C, we can also pass a pointer variable as an argument to a function. Let's see an example in which I'll create a function that accepts a pointer as an argument and change the value pointed by the pointer. So I'll create a function void find value. Here this function takes pointer as an argument, and inside the function asterisk num is equals to 39. Here the num parameter is a pointer variable and we have changed the value pointed by this pointer. Now let's create a number variable inside the main. So I'll create here int number and I'll assign value 21 to this, and I'll call the function by passing the address of the number. So I'll call the function find value bracket ampersand number. Since our function accepts a pointer variable which stores the memory address, we are passing the address of the number variable. Now let me print the value of the number. So I'll use print statement, printf, inside quotation, number, %d, comma, number. Let's run this code. As you can see, the value of the number is changed to 39. This happens because when we pass the address of a number variable, the pointer variable inside the function is assigned with the address of the number. So when we change the value at the memory address, the value of the number is also changed. Now let's see another example. In this example, we'll find the square of a number like before, but this time we'll use a pointer variable instead of a regular variable. Here I have the code from our earlier program. Let's remove this function. Now I'll create a find square function, void find square. And this function accepts a pointer variable as its parameter. So int asterisk number. Inside the function, I'll find the square of the number. So int square is equals to asterisk number multiplied with asterisk number. This syntax might look confusing for you. Here, asterisk number is the value pointed by the number pointer, and we are multiplying the value with itself. Now the square variable stores the square of the number. Now let me assign this to the value pointed by the number pointer. So asterisk number is equals to square. Now inside the main function, I'll change this find value to find square. So find square. I'll also modify this print statement. I'll write here square is. Now I'll run this code. As you can see, we have computed the square of the number.
If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box.
Just like regular variable, we can also return a pointer variable from a function. Let me show you an example. Here we have our code from our earlier program. Now suppose I want to return pointer from the function, not just compute the square. So first I'll change the return type of the function from void to integer pointer, that is int asterisk. Now inside the function, I'll add a return statement that returns a pointer. So return number. This statement returns the address pointed by number. Now to store the return value, I'll assign this function call to a variable. So int asterisk result is equals to this function call. Since the return value is an address, we have created a pointer to store the result. Now let's use this result variable to print the square value. I'll modify this print statement. Here I'll remove this square is, and I'll write here result is %d, and I'll remove this number and I'll write here asterisk result. Now let's run this program. As you can see, the return address stores the square of the number. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Let's see one more example to make it more clear for you. So I'll create a function that adds two numbers and returns the sum. Let me go back to my code editor. I'll remove these old code from here. And I'll remove these statements from here. So first I'll create a function that accepts three pointers. So I'll create a function here that is int asterisk add number, int asterisk num1 comma int asterisk num2 comma int asterisk sum. Inside the function, we will compute the sum of the number pointed by num1 and num2 and store the result to the address pointed by the sum. So we'll do asterisk sum is equals to asterisk num1 plus asterisk num2. Then I'll return the sum. So return sum. Now inside the main function, I'll create two variables, int number1, and I'll assign value 32, and another variable int number2, and I'll assign value 18 to this, and a sum variable to store the sum. Let me call the function by passing the addresses of three variables. So I'll call the function add numbers parenthesis ampersand number1 comma ampersand number2 comma, ampersand sum. Since the function returns the address, I'll assign this function call to a pointer. So int asterisk result is equals to this function. Finally, I'll print this using printf statement. So printf bracket inside quotation sum is %d comma asterisk result. Now let me run this program. As you can see, we have computed the sum of two numbers using the function and pointers. Now to revise what you have learned in this program, here is a programming task for you. Create a program to find the multiplication of two numbers using a function and a pointer. Here is how your program should work. Create a function that accepts 3 pointers. Inside the function, multiply values represented by 2 pointers and assign the result to the address of the third pointer. Inside the main function, create 3 variables, 2 variables with the value 13 and 9 and third variable to store their product. Call the function with addresses of the 3 variables as argument, store the return value inside a pointer and print the value pointed by the returned address. It's time for Programiz quiz. What type of value does the following function return? In this video, we will learn about struct in C. More specifically, we will learn to store related data together under a single name using struct. A struct is a collection of variables under a single name. The variables can be of different types. Suppose we want to store the name and age of a person. For this, we can create 2 variables and store name and age. However, since both the data are of same person, it would be better to create a single struct and put this data inside it. Remember, struct is often termed as structure in C, so don't get confused. They are mostly used interchangeably. Let's now start with the syntax of creating a struct. A struct in C starts with the struct keyword followed by the name of the struct. The curly braces indicates the body of the struct and the variable inside the struct are called members of the struct. When we define a struct, we are basically creating a data type just like int and double. In this example, the data type is struct person. So we can create variables of this struct person type just like creating variables of int and double types. Now let's create a variable of struct person type. Here, if you look into the syntax, you can see the syntax looks similar to creating regular variables, where struct person represents data type and this person1 represents the variable name. Now we can use these struct variables to access the members of struct. Now I'll add here person1.age is equals to 25 and person1.salary is equals to 4321.78. Here I have used dot operator to initialize the struct members age with the value 25 and salary with the value 4321.78 for the person1 variable. Now let's print the value. I'll use printf statement. Here is of person1 is %dn, comma person1.age, and another print statement that prints the salary of person1 that is in double, so 0.2 lf, comma person1.salary. Similarly, the same dot operator is used to access the value of struct members age and salary for the person1 variable. Now I'll complete this program. Here I'll add include stdio.h. I'll add here struct person curly braces double salary and int is. Now I'll run this code. Here you can see we have successfully initialized and accessed the struct members for the person1 variable. In this way, we can create as many struct variables as we want, and all struct members can use the age and salary members of the struct. Let me show you. Inside the main, I'll add here struct person 2. Then we can initialize and access the struct members for person2 variable as well. So I'll initialize person2 variable is equals to 31. Person2 dot salary is equals to 78,943.2, and I'll print this. So is of person2 colon %d comma person2 dot is, and printf salary of person2 is %.2 lf comma person2 dot salary. So I'll remove this space from here. Now let me run this code. You can see we have successfully used the struct for person2 as well.
If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box.
In this example, we are creating the struct variables in one line and assigning member variable in another line. Instead, we can simply create the struct variables and initialize members in the same line. Let me show you. I'll remove this part of code. So I'll remove this part as well. I'll remove these two lines of code. And so I'll simply write here struct person1 is equals to curly braces dot age is equals to 25 comma dot salary is equals to 4,321.78, and I'll close this curly braces, and another struct person2 is equals to curly braces dot age is equals to 31 comma dot salary is equals to 78,943.2, and let's close this. Now let me run this code. Here you can see we get the desired output. Also, we can create struct variables while defining the struct. Let me show you. In this previous code, I'll remove this part of code, and here I'll add these struct variables person1 comma person2. Now let me run this code. You can see we get the same output. While creating the struct variables, we have to use both the struct keyword and the name of the struct, which is too long. Instead, we can use an alias. The typedef keyword allows us to use an alias for struct. Let's see an example. Here we have our code from our earlier example. In this case, instead of struct person, we can use an alias with the help of typedef. Let me modify this code. Here I'll add here typedef in the struct definition and person at the end. Now this person can be used as an alias to struct. So we can now create a struct variable using person instead of struct person. So I'll remove this and I'll write here person. Now let me run this code. As you can see, we get the desired output. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button, hit subscribe if you haven't already. Let's keep the engagement score high so that more people can discover and enjoy these courses. Let's see one practical example of Struct. We'll create a program to add two complex numbers. We know that a complex number has two parts, real part and imaginary part. So while performing addition between two complex numbers, we always add the real part of complex number with the real part of another complex number and the imaginary part of complex number to the imaginary part of second complex number. Now you know the mechanism of the program, let's start writing code. First, I'll create a struct type def struct complex and curly braces, and it has members real and imaginary. So double real and double imaginary. So I'll just write imagine. So this represents the real and imaginary part of complex number, and we will add complex at the end of the struct. So complex here and semicolon. Now let's create two complex variables whose sum is to be found. So I'll write here complex C1 is equals to curly braces dot real is equals to 21.87 and its imaginary value is imagine is equals to 30, and then we'll close this and another variable complex C2 with value real value is equals to 13.34 and imaginary value dot imagine is equals to 112 suppose this is 112.23, and we will close this. Remember, we are assigning value while creating the complex variables. Now let's create another complex variable to store the sum of these two variables. So I'll create here complex sum. As mentioned earlier, let's add the real and the imaginary value of these variables independently and assign the results to the real and the complex part of this sum variable. So what I'll do is I'll add here sum dot real is equals to C1 dot real plus C2 dot real, and then sum dot imagine is equals to C1 dot imagine plus C2 dot imagine. Now let's print this. I'll use printf statement, printf bracket inside quotation result is %.2lf as it is double, so plus %.2lf, and we'll add here I for the complex number and sum dot real comma sum dot imagine. Here I have formatted the output to make our result look better. Now let me run this code. As you can see, we get the sum of two complex numbers. Now to revise what you have learned in this program, here is a programming task for you. Create a program to find the difference between three complex numbers. To perform the subtraction between complex numbers, you need to subtract the real part of one complex number from the real part of other complex numbers and the imaginary part of one complex number from other complex numbers. It's time for Programiz quiz. What is the name of the variable of the following struct? In this video, we'll learn about enums in C programming. We'll also learn to create variables of enum types and use them in our program. An enum is a type that has a fixed set of values. Let's see an example. Here we have used the enum keyword to create the enum named size. This enum contains 4 fixed values: small, medium, large and extra large. These are called enum constant. Now let's create enum variables from the above enum. So I'll create enum size, size. Here size is an enum type variable. This variable can now store one of the 4 values present in the enum size. So basically the value of size can be of either small, so I'll assign this here, size can be small, or this can be medium, so medium, or this can be large, or it can be extra large. Now let's complete this example and run the code, but before that let's first quickly learn about integral constant. In C, all enum constant are internally represented as fixed integer values known as integral constant. If we consider our earlier enum, the constant small is internally represented as 0, and similarly medium, large and extra large are represented as 1, 2 and 3 respectively. Let's verify this. I'll go back to my code editor. Here you can see the code from our earlier program. Now I'll complete this program, so I'll add here has include stdio.h, and here I'll add int min, and inside the curly braces return 0, and I'll cut this and I'll put it here. So yeah, I'll now print this using printf statement, and here %d comma size. As we know, enum constant are integer values internally, so I have used this %d format specifier. Now I'll run this. As you can see, we get 3 as an output because internally the value of extra large is 3. Now I'll change the value of size from extra large to small, and I'll run this again. This time we get the output 0. As we saw in our earlier example, the default integral values of enum constant starts from 0, so we get value 0, 1, 2 and 3 for enum constant small, medium, large and extra large. However, sometimes it might be necessary to print other values. For example, the value 0, 1, 2 and 3 for sizes small, medium, large and extra large does not make sense. Instead, we might want to print 27 for small, 31 for medium, 35 for large and 40 for extra large. In such situation, we can change the value of integral constant. Let me show you how. I'll go back to my code editor. Here you can see the code from our earlier example. Now I'll assign new value to these enum constant. So small is equals to 27 and medium is equals to 31, large is equals to 35 and extra large is equals to 40. Now let's create some more variables as well. First I'll cut this line of code, and now I'll modify this. I'll write here size 1 is equals to small, and similarly I'll write enum size size 2 is equals to medium, and for large and extra large I'll copy this 2 and I'll paste it here, and I'll change this size 3 and I'll write here large, and size 4 is extra large, so extra large. Then I'll print this. For that I'll use the same code from our earlier program, and I'll copy this and I'll paste it 3 more times. I'll change this from size 2, size 3, and this is size 4. Now let me run this code. As you can see, we get 27, 31, 35 and 40 for the enum constant small, medium, large and extra large. Now we are toward the end of this video, but before ending the video, let me give you a small tip. We have been using this format to create enum variable. However, we can also create enum variables while defining the enum. Let me show you. Here size is an enum variable, and like before, it can only store 4 values. Now let me run this code. Now this time we get the expected output. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the videos, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. Now to revise what you have learned in this program, here is a programming task for you. Create an enum with enum constant Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. Inside the main function, create 2 enum variables named weekend1 and weekend2. Assign values Sunday, Saturday to the variables respectively. Print the values of the weekend1 and weekend2. It's time for Programiz quiz. What is the name of the variable in the following enum? In this video, we will learn about dynamic memory allocation in C programming. More specifically, we will learn to allocate and destroy memory addresses while running the C program. Dynamic memory allocation allows us to allocate memory dynamically, that is after we run the program. Before we learn about dynamic memory allocation, let's first revise the concept of pointers. Here we have created a pointer variable ptr. This pointer variable stores the memory addresses of the var variable. In the print statement, we have used the pointer variable to access the value pointed by it. When I run this code, I'll get the output 32. We have already discussed pointers in our earlier videos. If you are confused how this program works, I highly recommend you to watch earlier videos. You can find the link somewhere on the screen. Now let's get back to our video. C provides 3 major functions to perform dynamic memory allocation: malloc, realloc and free. We will now learn about them one by one. The malloc function stands for memory allocation, is used to reserve a block of memory of the specified size. For example, suppose we need to allocate memory to store n variables of double type variable, then we can use the malloc function. Now let's see how we can use the malloc function. I want to allocate memory for n variables, so let me create the n variable, int n. Now let's create a pointer variable to store the address of allocated memory, int asterisk ptr. Now let's use the malloc function. I'll write here ptr equals to parenthesis int asterisk malloc n into size of int. Here n into size of int is the memory required to store n number of integer values. Suppose the value of n is 100, so let's change this to n equals to 100. Now we know the size of int is usually 4 bytes, so total space needed to store 100 double values is 100 into 4, that is 400 bytes. Now malloc function allocates 400 bytes of memory. Finally, we have used the typecasting so that the allocated memory is used to store integer type data. Here we have assigned the allocated memory to the ptr variable. In this case, the ptr variable stores the address of the first byte of the allocated memory, and we can use the ptr variable to access the remaining bytes as well. Once the work of allocated memory is completed, we use the free function to release the dynamically allocated memory. Here is the syntax to use the free function. Here the ptr is the pointer variable that stores the address of the memory allocated using malloc. Now that we know how malloc and free works, let's use them together in a program. But before that, let's get some engagement in the video so that we can keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button and hit subscribe if you haven't already. Let's get the engagement score high up
so that more people can discover and enjoy these courses. Here we have our code from our earlier program. Now let's complete this program first. So I'll add here has include stdio.h and int main inside the curly braces return 0. Now I'll cut this and put it there, and let's clean this up. Now it's ready. Okay, so we have our complete code. Now first I'll change the value of n from 100 to 4 for simplicity. Now let's provide 4 input values to store in the allocated memory. So I'll use printf. So printf, and here I'll write enter input values, and I'll use for loop. So int I is equals to 0, I is less than n plus plus I, and inside the curly braces I'll use scanf function, and inside quotation %d comma ptr plus I. Here we have allocated spaces for 4 elements, and ptr stores the address of the first element, so we can treat ptr as an array. And ptr plus I gives the ith element of the array, which we have already discussed in the pointer and array video. Now let's print the input values. I'll use the print statement first to print the message input values, and I'll use for loop again. Int I is equals to 0, I is less than n and plus plus I. Inside the for loop I'll print %d and comma asterisk ptr plus I. So asterisk parenthesis ptr plus I gives the value pointed by the ptr plus I pointer. While working with malloc, there might be a situation where the memory allocation fails. In such situation, the malloc function returns null. So let's create a condition to end the main function if the function cannot memory. In our code, I'll add if condition. If ptr equals to null, then we'll print memory cannot be allocated, and return 0. Here if the malloc function returns null, the condition becomes true, and this line memory cannot be allocated will be printed, and finally return 0 terminates the main function. Now finally let's use the free function to release the allocated memory. So I'll add here free function. Now let's run this code. I'll enter here 12, 21, 13 and 9. As you can see, we have allocated the memory using the malloc function.
If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box.
In our previous example, we have allocated 400 bytes of memory to store 4 integer values. Now suppose we need to store 2 more integer data. In this case, we use the realloc function to change the size of dynamically allocated memory. Now let's see the syntax to use realloc function. Here 6 into size of int is the new size allocated using the realloc function. Let's see an example now. Here I have the earlier code For simplicity, I'll remove this section to take input values. So I'll remove this, and here I'll print the memory addresses directly. So here I'll use printf inside quotation allocated memory, and I'll use for loop for and inside for int I is equals to 0, I is less than n, and plus plus I. Inside the curly braces, inside the for loop, I'll print the memory addresses. So %p comma ptr plus I. Now suppose I need 2 more memory spaces, so I'll add a new value of n with value 6. So I'll add here n is equals to 6. Then we will use realloc function to allocate 2 more spaces. So here ptr is equals to realloc function and ptr comma n into size of int. Finally, let's print the memory addresses of new allocated spaces. So printf and newly allocated memory \n, and we'll use for loop again. Int I is equals to 0, I is less than n, and here plus plus I. Inside for loop, I'll print the newly allocated memory addresses. So printf %p comma ptr plus I. I'll run this code. You can see the output here. Initially 4 spaces were allocated using the malloc, and then we increased the size from 4 to 6 using realloc. Now to revise what you have learned in this program, here is a programming task for you. Create a program that dynamically changes the size of an array. Create a pointer array like this, int asterisk ages, and then allocate 4 spaces for the array using the malloc function. Get 4 input values for the array. Print the array element using the pointer. Resize the array to store 6 elements using realloc. Assign 32 and 59 as the 5th and 6th element. You can see the hint on your screen. Then finally print all 6 arrays elements. It's time for Programiz quiz. What is the correct way to allocate memory to store 12 double data? In C programming, there are usually 3 steps involved while working with files. Open a file, perform file operation, close the file. Let's first learn to open a file. We use the file pointer to work with the file. Don't worry, you don't have to understand all about this pointer. Just remember this syntax for now. Now, once we create a file pointer, we then use the fopen function to open the file. Let me show you an example. Here I have this test.txt file. Now let's open this file. What I'll do is, I'll first create the file pointer, so file asterisk fptr. Now I'll use fopen function. Fptr is equals to fopen parenthesis inside quotation test.txt and another attribute that is r, that means read. Basically, opening a file is nothing but connecting our C program to the external file. In this case, we are connecting our main.c file to this test.txt file. Now, you can see this R. This R here indicates that we are opening the file in read mode. So we can only perform the read operation on the file. One thing you need to remember is that while opening the file in read mode, you need to make sure the file is already present in the specified location. Otherwise, the fopen function will return null. Let me show you. Now let me first complete this program. So I'll add here has include stdio.h
and int main inside curly braces return 0, and I'll cut this 2 lines of code and I'll paste it there. So let's make it more clearer. Okay, so now I'll add an if-else statement to check if file open is successful or not. So here I'll add if fptr is not equals to null, then we'll print file open successful. File open successful. Cool. Else we'll print file open unsuccessful. Unsuccessful. Now let's run this code. As you can see, file open is successful because test.txt file is present here. Now let me change the file to something else. Let's say test2.txt, and I'll save this and I'll run this again. As you can see, this time we get file open unsuccessful because the file does not exist and fopen returns null.
If you are enjoying this video, you will definitely love our interactive C programming course on Programiz PRO. The course includes easy to follow tutorials along with quizzes and challenges to practice and test your coding knowledge in real time. You will also be creating projects to experience how programming works in the real world, and in the end you will receive a certificate which will help you land your first job. Sign up now by using this QR code, or you can also use the link in the description box.
Now that we know how to open a file in read mode, let's read its content. In C, we use the fget function to read the content from the file. Let me show you an example. Here you can see the code from our earlier program. Now I'll change this test2 to test.txt. Now I'll remove this file open successful print statement from if condition. Now let's use fget's function to read the content of this file. So first we need to create an array to store the file content. So I'll add here char content square bracket 1000. Now let's read the content from this file to this array. So I'll write here fgets bracket content comma 1000 comma fptr, and I'll close this. Then I'll print it using printf statement. So %s comma content. I'll save this. Here fgets read the content of the file and stores it in the content array, and this 1000 is the size of the file that is to be read. Since our array is 1000, I have kept it 1000, and fptr is the pointer used to read the file. Now let's run this code. You can see we get the output. This is the text file. Here you can see in this file, this is the text file is the first sentence. We are only able to get the first sentence from the file because here we have used fgets, and fgets can only read the first sentence at a time. If we need to read all the lines, we can use a loop. Let me show you. So first I'll use this line as the condition of while loop. So I'll write here while and put this line inside parentheses. Here fgets function reads the content of the file. If the file read is successful, it returns true, otherwise it returns false. Hence our loop runs until there is some content to be read from the file. Now inside the loop, I'll print the file content. So I'll cut this and put it here. Now I'll save this. Now let's run this code. As you can see, we are able to read all the content of the file. Once a read operation is completed, it is a good practice to close the file. We use the fclose function to close the file. Here I'll add fclose function at the end, fptr. Now let's learn to write content to a file, but first we need to open our file in write mode. This means we need to use w as the second parameter instead of r with the fopen function. Let me show you. Here this test.txt file already exists, but if the file did not exist, a new file is created. Let me show you. I'll change this name to new file.txt. Now this new file will be created. I'll save this and I'll run this. You can see new file.txt file is now created here. Now let's add content to this file. We use fput function to write content to a file. Let me show you. I'll write here fputs parenthesis inside quotation. I'll write I love C programming, comma, fptr. Let me add one more message. Here I'll add fputs inside parenthesis. I'll write C programming series by Programiz is the best. So here comma fptr, and don't forget to close the file. So fclose fptr. Now let's run this code. Now when you open this file, you can see the file now includes the message. However, the message looks a bit odd. So in this file, I'll add here \n, and I'll save this, and let's run this again. Now you can see the file looks clean now. Here remember that initially the file did not exist. When we run the program for the first time, a new file is created. We then added the content to the file using fputs, and when we run the program for the second time, adding \n, the initial content of the file is erased and new content is added. So whenever we open a file in write mode, if the file already exists, all content will be erased. Let me show you that again. Now I'll change this message from I love C programming to new message 1, and I'll change this to new message 2, and I'll save this and I'll run this. Now you can see the old content is now replaced by new content. Now to revise what you have learned in this program, here is a programming task for you. Create a new file in write mode and add content. C is a fun programming language and I love using C language. Close the file, again open the file in read mode and read the content of the file. It's time for Programiz quiz. In this video, we'll learn about preprocessors and macros. Remember this #include stdio.h. We have been using it in all our programs. Today, you will know the exact meaning of this line, so let's get started. In this line, #include is preprocessor directive that includes the stdio.h header file in our program. Basically, a preprocessor preprocess our program before it is being compiled. For example, this line adds the stdio.h file in our program before the execution of the program. There are different types of preprocessor and all of them are represented by the # symbol at the beginning. Let's start with the most common preprocessor. As mentioned earlier, the #include preprocessor is used to include external header file in our program. For example, #include stdio.h. This code includes the stdio.h file in our program. Similarly, has include math.h. This code includes the math.h file in our program. Once we add the header file in our program, we can use all the functions present in the file. Remember printf and scanf? These functions were defined inside the stdio.h file. We are able to use this function because we have added the stdio.h file in our program. Similarly, we can use math function like sqrt and cbrt to compute the square root and cube root respectively, once we include the math.h header file in our program. Let's see an example. Here is the basic C program. Since we will always be printing some values, I have already added the stdio.h file. Now let's add the math.h file. So here I'll add has include math.h header file. Now inside main, let's create a variable int number. So int number, and I'll assign a value 36 to this. I'll now use sqrt function to compute the square root of this number. So I'll use sqrt bracket number. This function returns a double value, so I'll assign this to a variable. So double square root is equals to sqrt number. Now let me print the square root variable. I'll use printf statement, printf bracket inside quotation %.2lf comma square root. Now I'll run this code. As you can see, we get square root of 36, which is 6. Now let's find the cube root using cbrt function. I'll change this value of number from 36 to 125, and let me change this sqrt to cbrt. cbrt, and I'll change this variable name from square root to cube root. I'll change the variable name in here as well. Now let's run this code. Now this time you can see we get the cube root 5 of this number. In C, the hash defined preprocessor is used to define macros. For example, hash defined pi 3.1415. Here pi is a macro. A macro is a piece of code which is given a name. In our example, we have used pi to indicate the value 3.1415. Now whenever we need to add the value in our code, we use pi. Let's see an example. Now let me define pi macro. Has define pi 3.1415. Now I'll print the value of pi inside the main. So I'll use printf statement. Here printf inside quotation %.4lf comma pi, and I'll run this code. As you can see, we get the value 3.1415 when we print pi. Let's see one more example. Suppose I want to compute the area of circle. I have already defined pi macro. Now let me create the radius variable. First I'll create radius variable here. Double radius is equals to 12.4, and I'll now compute the area. So here double area is equals to pi into radius into radius. Here I have used pi macro. This will be replaced by the value 3.1415. Now let me print the area. I'll modify this print statement. So I'll modify this print statement and I'll put here area. I'll run this code. You can see we have successfully computed the area of the triangle. Okay guys, we need your support to keep these types of content free for all users. YouTube really likes engagement on the video, so leave a comment below, press that like button, hit subscribe if you haven't already. Let's get the engagement score high up so that more people can discover and enjoy these courses. As mentioned earlier, macros are piece of code that is given some name. Hence, we can also define a complete function as a macro. Let's see an example. We have computed the area of circle. Instead of computing the area like this, we can define a function macro that computes the area and use the code in our program. Let me show you. Here, after the define pi, I'll write here has define circle area parenthesis r another parenthesis. I'll write here pi into r into r. This is the macro function. It takes the single parameter r, that is the radius of the circle, and computes the area. Now let's use this in our code to compute the area. So I'll remove this pi into radius from the code, and I'll add here circle area and here radius. So let me run this. As you can see, we get the same output. Now to revise what you have learned in this program, here is a programming task for you. Create a program to find the square root of a number using the sqrt function and macro together. Here is how your program should work. Include the math.h header file, define a macro function, square root bracket n. This macro function should use the sqrt function to find the square root of the parameter n. Inside the main function, use the square root macro to compute the square root. It's time for Programiz quiz. What symbol is used to begin a preprocessor directive? Comment your answer below. See you in the next video. Happy programming!